Hello and welcome to a moment of calm. Find a comfortable spot, stretch out, and let the gentle rhythm of this tutorial start to wash over you. Close your eyes if you like, or simply let your thoughts slow down. This is a space for learning, but also for relaxation. As we explore the world of Ruby together, may the words flow like a soothing stream, guiding you gently through each step. If you're enjoying the journey, don't forget to like and subscribe for more relaxing coding tutorials. Let the coding begin. Ruby is a dynamic, object-oriented, and interpreted programming language that emphasizes simplicity and productivity. It was created in 1995 by Yukihiro Matsumoto, who designed it to make programming enjoyable and efficient. Ruby's syntax is known for its natural and readable structure, which makes it accessible for beginners and allows experienced developers to write concise and expressive code. This language is widely used in web development, particularly with frameworks like Ruby on Rails, which enable rapid application development. Beyond web projects, Ruby is also popular for scripting and automation tasks, thanks to its flexibility and powerful built-in libraries. Learning Ruby is an excellent choice for several reasons. Its syntax is designed to be intuitive, making it easier for newcomers to grasp programming concepts without getting bogged down by complex syntax rules. The Ruby community is vibrant and supportive, offering a wealth of resources, tutorials, and open-source libraries called gems, which extend the language's capabilities. Ruby's versatility allows it to be used for a wide range of applications, from building web applications and APIs to creating command line tools. Major companies like GitHub, Shopify, and Airbnb have adopted Ruby for their platforms, proving its reliability and scalability in real-world scenarios. Setting up Ruby on your system is straightforward, though the exact steps may vary depending on your operating system. You can install Ruby using tools like rbenv or RVM, which help manage multiple Ruby versions, or you can use official installers provided by the Ruby project. Once installed, verifying the installation with commands like rubyv and gemv ensures that Ruby and its package manager, gem, are functioning correctly. Choosing an appropriate development environment is also important. Many developers prefer text editors like VS Code or Sublime Text for their lightweight and customizable features. Additionally, to Tools like Bundler are essential for managing dependencies in Ruby projects, allowing you to keep your code organized and up to date. Ruby's basic syntax is designed to be simple and readable. Comments in Ruby start with a hash symbol, which is used to annotate code and improve clarity. Putting text to the console is done using the puts or print methods, where puts adds a new line after the output, and print does not. Variables in Ruby are dynamically typed, meaning you can assign values to them without declaring their type explicitly. For example, name equals Ruby and age equals 25 are valid variable assignments. Ruby supports a variety of operators, including plus for addition, minus for subtraction, multiply for multiplication, divide for division, and modulo for finding the remainder of a division. These operators allow you to perform calculations and manipulate data efficiently. Ruby has a rich set of data types that enable you to work with different kinds of information. Numeric types include integers, which are whole numbers, and floats, which represent decimal values. Strings are used to store text and can be enclosed in either double quotes or single quotes, with slight differences in behavior. Booleans, true and false, are used for logical operations and condition checks. Symbols, denoted by a colon, are immutable and often used as keys in hashes for efficiency. Arrays store ordered collections of elements, while hashes are key-value pairs that allow you to retrieve data using specific keys. These data types form the foundation for building complex programs and managing data effectively. Control structures in Ruby allow you to make decisions and repeat actions based on conditions. Conditional statements like if-else-if and else enable you to execute different blocks of code depending on whether a condition is true or false. Loops such as for, while, until, and each let you iterate over collections or perform tasks repeatedly. For example, an if statement can check if a person's age is greater than 18 and output adult, if the condition is met, or minor otherwise. These structures are essential for creating dynamic and responsive applications, as they allow your code to adapt to different scenarios and inputs. In Ruby, functions are referred to as methods, and they are defined using the def keyword followed by the method name and a block of code. For instance, a method called greet can take a parameter like name and output a personalized message. Ruby methods can return values explicitly using the return keyword, or implicitly through the last evaluated expression. This flexibility makes it easy to encapsulate logic into reusable blocks, improving code organization and maintainability. Methods are a core part of Ruby's object-oriented design, allowing you to define behaviors that can be called on objects throughout your program. Ruby is a powerful and flexible language that offers a wide range of possibilities for modern development. By mastering the basics, such as syntax, data types, control structures, and methods, you lay a strong foundation for more advanced programming concepts. The next step is to practice by building small projects, which will help reinforce your understanding and improve your skills. Additionally, exploring resources like the official Ruby documentation, online tutorials, and community forums will provide further guidance and support. As you continue learning, you'll discover how Ruby's simplicity and versatility can be leveraged to create innovative and efficient solutions. Ruby is a dynamic, object-oriented programming language known for its simplicity and productivity. It allows developers to write clean and readable code while offering powerful features for building robust applications. A proper development environment is essential because it ensures that your Ruby projects run smoothly, avoids conflicts, and provides the tools needed for efficient coding. Today, we will guide you through installing Ruby, configuring necessary tools, and verifying your setup to get started with Ruby programming. To install Ruby on Windows, visit the official Ruby installer website at rubyinstaller.org. Download the latest stable version, such as Ruby 3x, which offers improved performance and features. During the installation process, make sure to select the option to add Ruby to your system path. This step is critical because it allows you to run Ruby commands from any location in the command prompt. After installation, open the command prompt and type Ruby v to confirm the installation. This command will display the installed Ruby version, ensuring everything is set up correctly. On macOS, the recommended method is to use Homebrew, a package manager that simplifies software installation. First, open the terminal and run the installation command for Homebrew. Once installed, use the brew install Ruby command to download and set up Ruby. After installation, check the version by typing Ruby v in the terminal. It is also important to ensure that Xcode command line tools are installed, as they provide essential compilers and libraries required for building Ruby and other development tools. For Linux users, particularly those on Ubuntu or Debian, start by updating your package list with the command sudo apt update. This ensures you have the latest information about available packages. Next, install Ruby by running sudo apt install Ruby full, which includes the complete Ruby development environment. Verify the installation with Ruby V. For advanced users, tools like rbenv or rvm can be used to manage multiple Ruby versions, allowing you to switch between different versions as needed for various projects. Setting up a development environment involves choosing a code editor that suits your needs. Popular options include VS Code, Sublime Text, or RubyMine, each offering features tailored for Ruby development. Install essential gems, such as those listed in your project's gem file, by running bundle install. Configure environment variables to ensure the system recognizes Ruby executables. Finally, set up a version control system like Git to track changes and collaborate effectively on your projects. To test your Ruby installation, start by checking the Ruby version with Ruby V and the Ruby Gems version with Gem V. These commands confirm that both Ruby and its package manager are functioning correctly. Next, create a simple script by typing puts hello Ruby into a text file and saving it with a RB extension. Run the script using the Ruby command. Additionally, use herb, the interactive Ruby shell, to experiment with code snippets and test functionality in real time. If you encounter issues, start by checking the path variable to ensure Ruby is accessible from the command line. For version conflicts, tools like rbenv or rvm can help manage multiple Ruby versions. Update your gems regularly using gem update to ensure you have the latest features and security patches. If problems persist, consult the official Ruby documentation or community forums for support. These resources are invaluable for troubleshooting and learning best practices. Ruby is a dynamic and object-oriented programming language that emphasizes simplicity and productivity. This means that Ruby allows for flexible variable types and treats everything as an object, enabling powerful and intuitive code structures. A Ruby program consists of a series of instructions written in Ruby syntax, which the interpreter can execute. These programs can perform a wide range of tasks, from simple calculations and data manipulation to interactive user experiences, making Ruby a versatile tool for developers. To begin working with Ruby, you need to install it from the official website at rubylang.org. This ensures you get the latest stable version and avoids potential issues with third-party distributions. Once installed, you can use any code editor, such as Visual Studio Code or Sublime Text, which offer features like syntax highlighting and code completion. To verify that Ruby is properly installed, open your terminal and type the command Ruby v. This will display the installed version of Ruby, confirming that the setup is complete and ready for use. Creating your first Ruby program is straightforward. Open a text editor, such as Notepad or your preferred code editor, and create a new file. Save it with a RB extension, for example, hello RB. This extension tells the system that the file contains Ruby code. In the file, type the following line of code, puts hello world. This line uses the puts method to output the string hello world to the console. Once saved, you can run this program using the terminal. To run your Ruby program, open the terminal and navigate to the directory where your hello RB file is saved. Use the cd command followed by the directory path to change into the correct folder. Once there, type the command Ruby hello RB and press enter. The terminal will execute the code, and you should see the output hello world displayed. This confirms that your program is working as expected and that Ruby is properly configured on your system. Let's break down the code in your first program. The puts method is used to print text to the console, making it a fundamental tool for displaying information. The text hello world is enclosed in double quotes, which in Ruby signifies a string, a sequence of characters. This simple example demonstrates Ruby's straightforward syntax and its ability to handle basic output. Even though the program is short, it highlights how Ruby's design prioritizes readability and ease of use. To make your programs more interactive, you can use the gets method to accept user input. For instance, the code name equals getSchomp reads a line of text from the user and stores it in the variable name. The chomp method removes the newline character that often follows user input, ensuring the output is clean. When combined with puts, like puts hello name, the program can greet the user by name. This dynamic interaction is a key feature of Ruby, allowing programs to respond to user actions in real time. Ruby follows specific syntax rules to ensure code clarity and consistency. First, it is case sensitive, meaning that my var and my var are treated as distinct variables. This requires careful attention to variable and method names. Second, Ruby does not require semicolons to end lines, as each line is typically separated by a newline. Finally, comments are used to explain code and are denoted by a hash symbol for single lines or equals begin and equals end for multi-line comments. These rules help maintain organized and readable code. You have successfully written and executed your first Ruby program, gaining hands-on experience with key concepts like output, user input, and syntax. The puts method, strings, and basic structure form the foundation of Ruby programming, while the ability to interact with users expands the program's functionality. To reinforce these ideas, try modifying the program to add new features, such as asking for multiple inputs or performing simple calculations. Practice will help you master Ruby's capabilities and build more complex applications. Variables in Ruby are essential tools for storing and retrieving data values throughout your code. They act as containers that hold information, allowing you to reference and manipulate that data later. One of the unique features of Ruby is its dynamic typing system, which means you don't need to specify the type of a variable when you create it. Instead, Ruby automatically determines the type based on the value assigned. For example, if you assign the number 5 to a variable, Ruby recognizes it as an integer. And if you later assign a string, it seamlessly changes the variable's type. Ruby has 3 primary types of variables: local variables, which are confined to the scope they are defined in; instance variables, which belong to an object and persist across method calls; and class variables, which are shared among all instances of a class. Assigning values to variables is straightforward, using the equal sign to link a variable name to a value. This simplicity makes Ruby a flexible and user-friendly language for beginners and experienced developers alike. Understanding data types is fundamental to working with Ruby effectively. Data types define the kind of data a variable can hold and dictate the operations you can perform on it. Ruby offers a wide range of data types, including integers, which represent whole numbers, floats, which handle decimal values, strings, which store text, booleans, which express true or false states, symbols, which are lightweight identifiers, arrays, which organize multiple elements in order, hashes, which map keys to values, and nil, which signifies the absence of a value. Each data type comes with its own set of methods and behaviors. For instance, a string can be manipulated with methods like length or upcase, while an integer can be used in arithmetic operations. Recognizing and utilizing the correct data type ensures your code is efficient, readable, and less prone to errors. This diversity of data types allows Ruby to handle a broad spectrum of programming tasks with ease. Integers and floats are two of the most commonly used data types in Ruby, representing numerical values in different forms. Integers are whole numbers without decimal points, such as 5, -3, or 100. They are ideal for counting, indexing, and performing calculations that require exact values. Floats, on the other hand, represent numbers with decimal points, like 3.14, -0.5, or 2.0. These are useful for scientific computations, financial calculations, and any scenario where precision with decimals is necessary. Both integers and floats support standard arithmetic operations like addition, subtraction, multiplication, and division. However, it's important to note that operations involving floats may introduce rounding errors due to the way they are stored in memory. Ruby's ability to handle both types seamlessly makes it a powerful tool for numerical programming. Strings in Ruby are used to represent text and are enclosed in either single quotes or double quotes. While both types of quotes serve the same basic purpose, there is a key difference. Double quotes allow for string interpolation, which lets you embed expressions directly within the string. For example, using double quotes, you can write "the value is variable" to insert the value of a variable into the string. Single quotes, however, treat the content as a literal string without interpolation. Strings can also be concatenated using the plus operator, which joins two strings into one. Ruby provides numerous built-in methods for manipulating strings, such as length to determine the number of characters, upcase to convert all letters to uppercase, downcase to convert them to lowercase, and split to divide the string into parts based on a delimiter. These methods make string handling in Ruby both versatile and intuitive. Booleans and symbols are two distinct data types that play critical roles in Ruby programming. Booleans represent logical states and can only have one of two values, true or false. They are essential for decision-making in control structures like if statements and loops. Symbols, in contrast, are immutable identifiers that are often used as keys in hashes or as method names. They are denoted by a colon followed by a name, such as name or age. Unlike strings, symbols are not subject to change once created, making them more efficient in terms of memory and performance. This immutability also ensures consistency when using symbols as keys in hashes, where the same symbol always refers to the same value. While Booleans are used to evaluate conditions, symbols provide a lightweight and reliable way to reference data, contributing to cleaner and more efficient code. Arrays and hashes are two of the most versatile data structures in Ruby, allowing you to organize and access collections of data. An array is an ordered list of elements, which can be of any data type, such as numbers, strings, or even other arrays. For example, an array might contain the numbers 1, 2, and 3, or a mix of strings and Booleans. Elements in an array are accessed using their index, which starts at 0. Hashes, on the other hand, are collections of key-value pairs, where each key is unique and maps to a corresponding value. This makes hashes ideal for storing and retrieving data based on a specific identifier. For instance, a hash might store a person's name as the key and their age as the value. Accessing elements in a hash is done using the key rather than an index, making it easy to look up information based on meaningful labels. Both arrays and hashes are fundamental to building complex data structures in Ruby. Nil class is a special data type in Ruby that represents the absence of a value. When a variable is not assigned a value, it defaults to nil, which can be useful for checking if a variable has been initialized. For example, if a method returns nil, it indicates that no value was provided or that the operation failed. Type conversion is another important concept in Ruby, allowing you to change the data type of a variable when needed. Ruby provides methods like toy, tof, and to's to convert values between types. For instance, the to's method can convert an integer into a string, enabling you to combine numbers with text in a string. Understanding nil and type conversion helps prevent errors and ensures that your code handles unexpected situations gracefully. These features make Ruby a flexible language for handling diverse data scenarios. In summary, variables and data types are the building blocks of Ruby programming, enabling you to store, manipulate, and organize information effectively. Variables act as containers for data, while data types define the nature of that data and the operations you can perform on it. Ruby's dynamic typing system simplifies development by eliminating the need to explicitly declare types, allowing for more flexible and expressive code. Mastering these concepts is essential for writing robust and efficient Ruby programs. As you progress, practicing with different data types in real-world scenarios will deepen your understanding and improve your ability to solve complex problems. By leveraging the power of variables and data types, you'll be well equipped to tackle a wide range of programming challenges in Ruby. Operators and expressions are fundamental components of the Ruby programming language. Operators are symbols or keywords that perform specific operations on values, such as adding numbers, comparing values, or combining conditions. Expressions are combinations of variables, literals, and operators that evaluate to a single value. Together, they enable the execution of tasks, from simple calculations to complex decision-making processes. Understanding operators and expressions is essential for building the logic and computations that drive Ruby programs. They form the building blocks for writing efficient and readable code, allowing developers to manipulate data and create dynamic functionality. Ruby includes several types of operators, each serving a distinct purpose. Arithmetic operators handle mathematical operations like addition, subtraction, multiplication, division, modulus, and exponentiation. Comparison operators determine relationships between values, such as equality, inequality, or ordering. Logical operators combine or invert Boolean values, allowing for conditional logic. Assignment operators simplify the process of storing values in variables, often with shorthand notations. These categories of operators work together to create flexible and powerful code, enabling developers to perform a wide range of tasks with clarity and precision. Let's explore arithmetic operators in detail. The plus symbol represents addition, as in 5 plus 3 equals 8. The minus symbol denotes subtraction, such as 10 minus 4 equals 6. Multiplication is indicated by the asterisk. For example, 2 multiplied by 5 equals 10. Division is represented by the forward slash, like 10 divided by 2 equals 5. The modulus operator, represented by the percent sign, returns the remainder of a division, such as 7 modulus 3 equals 1. Finally, the exponentiation operator, denoted by 2 asterisks, raises a number to a power, as in 2 to the power of 3 equals 8. These operators form the foundation for numerical computations in Ruby. Comparison operators are used to evaluate relationships between values, returning a Boolean result of true or false. The equal to operator, represented by 2 equal signs, checks if 2 values are identical, such as 5 equals 5. The not equal to operator, using an exclamation point followed by an equal sign, verifies if values differ, like 5 not equal to 3. The greater than operator, represented by a greater than sign, determines if one value exceeds another, such as 7 greater than 4. The less than operator, using a less than sign, checks if one value is smaller, like 2 less than 6. The greater than or equal to and less than or equal to operators expand on these comparisons, allowing for inclusive checks. These operators are critical for decision-making in programs. Logical operators enable the combination of multiple conditions, allowing for more nuanced control flow. The AND operator, represented by 2 ampersands, returns true only if both conditions are true, such as true and false. The OR operator, using 2 vertical bars, returns true if at least one condition is true, like true or false. The NOT operator, denoted by an exclamation point, inverts the Boolean value of a condition, such as not true. These operators are frequently used in conditional statements, such as if conditions, to create complex logic that directs program behavior based on multiple criteria. Assignment operators streamline the process of storing values in variables. The basic assignment operator, represented by an equal sign, assigns a value directly, such as x equals 5. Compound operators like add and assign, represented by a plus sign followed by an equal sign, simplify updating variables, such as x plus 3 equals 8. Subtract and assign, using a minus sign followed by an equal sign, reduces a variable's value, like x minus 2 equals 6. Multiply and assign, represented by an asterisk followed by an equal sign, scales a variable, such as x multiplied by 2 equals 12. Divide and assign, using a forward slash followed by an equal sign, adjusts a variable through division, like x divided by 3 equals 4. These operators enhance code efficiency and readability. Understanding operator precedence is crucial for accurate calculations. Parentheses can override default precedence, ensuring specific operations are evaluated first. For example, exponentiation, represented by 2 asterisks, has higher precedence than multiplication. So too to the power of 3 multiplied by 2 equals 16. Logical operators, such as and or, have lower precedence than comparisons, meaning conditions involving comparisons are evaluated before logical combinations. Consider the expression 3 plus 5 multiplied by 2, which equals 13, not 16, because multiplication takes precedence over addition. Proper use of precedence rules prevents errors and ensures predictable outcomes. Expressions in Ruby are combinations of variables, literals, and operators that evaluate to a single value. For instance, 2 plus 3 evaluates to 5. Expressions are integral to conditionals, loops, and assignments, enabling dynamic behavior in programs. A complex expression like x greater than 5 and y less than 10 evaluates to a Boolean result, guiding program flow. Expressions can be nested, allowing for intricate calculations and decisions. Mastering expressions enhances the ability to write concise, functional code that efficiently processes data and executes tasks. Let's examine practical examples of operators and expressions. In arithmetic, 10 plus 2 multiplied by 3 equals 36. For comparisons, apple equals orange evaluates to false. Logical operations might involve age greater than or equal to 18 or student equals true, determining eligibility. Mixed expressions combine multiple operations, such as x to the power of 2 plus y multiplied by 3 greater than 100. These examples illustrate how operators and expressions are applied in real-world scenarios, demonstrating their versatility and importance in programming. Operators and expressions are the backbone of Ruby's logic and computation capabilities. They empower developers to perform calculations, make decisions, and manipulate data efficiently. By mastering their usage, programmers can write cleaner, more effective code. Practicing with real-world examples reinforces understanding, making it easier to apply these concepts in diverse situations. As you continue learning Ruby, focus on experimenting with operators and expressions to build confidence and proficiency in creating dynamic, functional programs. Conditional statements are the building blocks that allow programs to make decisions based on specific conditions. They act like a traffic light, directing the flow of code execution depending on whether a condition is true or false. These statements are essential in any programming language because they enable programs to respond dynamically to different scenarios. In Ruby, the key constructs for implementing conditional logic are if-else, else-if, and case. These tools help developers create flexible and responsive code that can handle a wide range of inputs and situations. The if statement is the most fundamental way to introduce decision-making into a program. It executes a block of code only if a specified condition evaluates to true. For example, if a person is 18 years old or older, the program can print a message indicating they are an adult. The syntax for an if statement starts with the keyword if followed by a condition. The code block that follows is enclosed within the if and end keywords. This structure allows the program to make simple decisions based on a single condition. The else statement provides an alternative path for the program to follow when the if condition evaluates to false. It ensures that there is a fallback option in case the initial condition is not met. For instance, if a person is not 18 or older, the else block can print a message indicating they are a minor. The else clause must always come after the if statement and before any else if or else if clauses. This structure allows the program to handle both true and false outcomes of a condition. The else if or else if statement adds the ability to check multiple conditions sequentially. It allows the program to evaluate additional conditions after the initial if statement. For example, in a grading system, if a student's score is 90 or above, they receive an A. If not, the program checks if the score is 80 or above for a B, and so on. This chain of conditions helps avoid deeply nested if statements and keeps the code more readable. The else if keyword is used to add these additional checks, making the code more efficient and easier to manage. The case statement is a powerful alternative to multiple if-else if conditions when checking a single variable against several possible values. It starts with the keyword case, followed by the variable being evaluated. Each when clause specifies a value that the variable might match, and the corresponding code block is executed if a match is found. For example, if the variable day is set to Monday, the program can print a message about the start of the week. If no match is found, the else clause provides a default action. This structure is particularly useful for handling a variety of cases in a clean and organized way. Case statement and if else structure both serve the purpose of conditional logic, but they are suited to different scenarios. The case statement is ideal for checking a single variable against multiple values, making the code more readable and concise. On the other hand, the if-else structure is better for handling complex conditions involving logical operators or multiple variables. While both can be used interchangeably, choosing the right one depends on the specific requirements of the code. Understanding when to use each ensures that the code remains efficient and maintainable. Conditional statements are widely used in real-world applications to handle various situations. For example, when validating user input, the program can check if the input meets certain criteria, such as being a valid email address or a positive number. In a grading system, the program can use case or if else statements to determine the appropriate grade based on a score. These examples demonstrate how conditional logic is essential for creating interactive and responsive programs that can adapt to different inputs and scenarios. While conditional statements are powerful, they can also lead to errors if not used carefully. One common mistake is forgetting to include the end keyword, which closes the if or case statement, leading to syntax errors. Another issue is using the assignment operator equals instead of the equality operator equals, which can cause unexpected behavior. Additionally, overusing nested conditions can make the code difficult to read and maintain. To avoid these pitfalls, it is important to structure the code clearly, use appropriate indentation, and consider alternatives like case statements when applicable. In conclusion, conditional statements are a critical component of programming that enable dynamic decision-making. They allow programs to respond to different scenarios, making the code more versatile and efficient. By mastering the use of if, else, else-if, and case statements, developers can create well-structured and readable code. Practicing with real-world examples helps reinforce these concepts and ensures that the code is both functional and maintainable. As you continue to learn, remember that understanding when and how to use each conditional structure is key writing effective and elegant programs. Loops and iteration are essential for repeating code blocks in Ruby. When you need to perform the same action multiple times, loops save time and reduce redundancy. They help automate repetitive tasks, like processing data from a list or performing calculations on a range of numbers. For example, if you have a list of usernames, you can use a loop to print each name without writing separate lines for each entry. This is especially useful when working with collections of data, such as arrays or hashes. In Ruby, the key loop types include for, while, and each. Each of these has unique use cases. The each method is particularly common for arrays and hashes because it directly interacts with the elements in a clean and readable way. Understanding these tools allows you to write more efficient and maintainable code. The for loop in Ruby has a simple syntax that is easy to understand. It works by iterating over a collection, such as a range, array, or any object that can be enumerated. The basic structure is for variable in collection do. And, for instance, if you want to print numbers from 1 to 5, you can use a range like 1, 5 and loop through each value. This is straightforward for ranges, but it's worth noting that for loops are less commonly used in Ruby compared to the each method. Why? Because each is more idiomatic and integrates better with Ruby's object-oriented approach. For example, when working with arrays, using each allows you to access each element directly without worrying about indexes. While for loops can be useful for specific scenarios, the each method is generally preferred for its clarity and consistency with Ruby's design principles. The while loop is a flexible tool that executes a block of code as long as a condition remains true. Its syntax is while condition do. And, for example, if you start with a variable I set to 0 and want to print numbers until I reaches 5, you can use a while loop with the condition I5. Inside the loop, you must update the variable to ensure the condition eventually becomes false, or you risk creating an infinite loop. Infinite loops can cause programs to crash or become unresponsive, so it's crucial to manage the condition carefully. While loops are ideal when the number of iterations is unknown, such as waiting for user input or processing data until a specific event occurs. However, because the condition is checked before each iteration, you need to ensure it's properly initialized and updated to avoid unexpected behavior. The each method is one of the most commonly used iteration tools in Ruby. It allows you to loop through each element in a collection, such as an array or hash, without manually managing indexes. The syntax is collection each item, where item represents each element in the collection. For example, if you have an array of numbers, you can use each to print each number. This approach is clean and avoids side effects, making the code easier to read and maintain. Unlike for loops, which can sometimes feel more procedural, each is deeply integrated into Ruby's enumerable module, which provides a wide range of methods for working with collections. This makes each a natural choice for iterating over arrays, hashes, and other enumerable objects. By using each, you can focus on the logic of what you want to do with each element rather than how to access it. Iteration methods in Ruby go beyond simple loops and offer powerful ways to manipulate collections. Common methods include each, map, select, reject, and inject. Each of these serves a specific purpose. The map method transforms elements in a collection, such as doubling each number in an array. The select method filters elements based on a condition, like finding all even numbers. The reject method does the opposite of select, removing elements that meet a condition. The inject method accumulates values, often used for summing or combining elements. These methods are functional in nature, meaning they avoid modifying the original collection and instead return new values. This approach reduces side effects and makes code more predictable. For example, using map to create a new array of squared numbers is more concise and readable than using a loop to manually assign each value. By mastering these methods, you can write more expressive and efficient Ruby code. When choosing between for, while, and each, it's important to consider their strengths and weaknesses. The for loop is straightforward for ranges, as it directly iterates through each value. However, it's less idiomatic in Ruby compared to each, which is preferred for collections. The while loop is highly flexible, allowing you to control the iteration based on any condition. But this flexibility comes with responsibility. Since the condition is checked before each iteration, you must ensure it eventually becomes false to avoid infinite loops. The each method, on the other hand, is the most Ruby-like and avoids many of the pitfalls associated with manual loop management. It's designed to work seamlessly with enumerable objects, making it the go-to choice for most iteration tasks. Ultimately, the best approach depends on the specific problem you're solving and the structure of your data. Understanding when to use each tool ensures your code is both effective and easy to understand. Adhering to best practices when using loops and iteration can significantly improve the quality of your Ruby code. First, always use each for iterating over collections, as it aligns with Ruby's design and reduces the risk of errors. Avoid infinite loops by ensuring conditions are properly managed, especially with while loops. For example, incrementing a counter or updating a state variable is crucial to prevent the loop from running indefinitely. When the number of iterations is unknown, while loops are a good choice, but you should always test the exit condition thoroughly. Keep loop bodies concise and readable by breaking complex logic into smaller methods, or using iteration methods like map and select. This not only makes the code easier to follow, but also reduces the chance of bugs. By following these guidelines, you'll write cleaner, more maintainable Ruby programs that are easier to debug and extend. Loops and iteration are fundamental to writing efficient and effective Ruby code. They allow you to handle repetitive tasks, process large data sets, and create dynamic programs. While for while and each have their own use cases, each method has its own strengths. For example, for loops are simple for ranges, while loops offer flexibility for unknown iteration counts, and each is the most idiomatic choice for collections. Understanding iteration methods like map, select, and inject further enhances your ability to work with data in a functional and expressive way. As you practice using these constructs with arrays, hashes, and ranges, you'll develop a deeper intuition for when and how to apply them. This knowledge will not only make your code more efficient, but also improve its readability and maintainability. Keep experimenting with different scenarios to solidify your understanding and become more confident in your Ruby programming skills. Methods are reusable blocks of code that perform specific tasks. They are defined using the keyword def and ended with the keyword end. This structure allows you to encapsulate logic that can be called multiple times, which improves code organization and reduces repetition. For example, a method called greet could take a name as input and output a personalized message. This approach makes your code cleaner and easier to maintain. Imagine if you had to write the same code over and over again. Methods eliminate that redundancy. The syntax is straightforward, and once defined, methods can be invoked anywhere in your program. The syntax for defining a method is def followed by the method name, then parameters, and ending with end. Parameters are optional, but they are often used to pass data into the method. For instance, a method called add could take two parameters, a and b, and return their sum. Ruby methods automatically return the result of the last evaluated expression, so you don't always need to use the return keyword. This makes the code concise. If you write a plus b as the last line, the method will return that value without needing an explicit return statement. This feature is powerful, but requires careful attention to what the last line of the method does. Parameters are the placeholders in a method definition, while arguments are the actual values passed when the method is called. Ruby supports both positional and keyword arguments. Positional arguments are straightforward, as the order of the arguments matches the order of the parameters. For example, a method called greet might take name and greeting as parameters, and when called, you would pass the name first and the greeting second. Ruby also allows keyword arguments, which can make the code more readable by explicitly stating the purpose of each argument. This flexibility helps avoid confusion, especially when a method has many parameters. Ruby uses a concept called pass-by-object reference for parameter passing. This means that when you pass an object to a method, you are passing a reference to that object, not a copy. If the object is mutable, such as an array, changes made inside the method will affect the original object outside the method. For example, if you pass an array to a method that appends an element to it, the original array will reflect that change. However, if you reassign the parameter inside the method, such as setting it to a new array, the original variable outside the method remains unchanged. This behavior is important to understand to avoid unintended side effects in your code. Default parameters allow you to set values for parameters if no argument is provided when the method is called. This is done by assigning a default value to the parameter in the method definition. For example, a method called greet could have a default value of guest for the name parameter. If no name is provided, the method will use guest by default. This is useful for making certain arguments optional, which can simplify method calls. Another example is a logging method that has a default level of info, so you don't have to specify it every time. Default parameters make your code more flexible and user-friendly. Variable length arguments allow a method to accept any number of arguments. In Ruby, this is achieved using the asterisk operator, which collects all the arguments into an array. For instance, a method called sum could take multiple numbers as arguments, and the asterisk operator would gather them into an array called numbers. You can then process this array, such as by summing all the elements. This is particularly useful when you want a method to handle a dynamic number of inputs. The asterisk operator is a powerful tool for creating flexible methods that can adapt to different scenarios. Methods in Ruby can accept blocks of code, which are executed within the method. Blocks are passed using curly braces or the do and end keywords. For example, a method called iterate could take a collection and a block, then iterate over the collection, yielding each item to the block. This allows you to customize the behavior of the method without modifying its code. Blocks are anonymous functions that can be passed to methods, making your code more modular and reusable. They are a fundamental part of Ruby's design, enabling powerful constructs like loops and iterators. The return value of a method is determined by the last evaluated expression. Ruby automatically returns this value without needing an explicit return statement. However, you can use the return keyword to exit the method early and specify a return value. For example, a method called iceven could check if a number is even and return true immediately if it is, otherwise returning false. This allows for more controlled and readable code. Understanding when to use return versus relying on the last line is essential for writing clear and efficient methods. When working with methods, there are several common pitfalls to avoid. Modifying mutable objects like arrays or hashes inside a method can have unintended side effects, as changes to these objects persist outside the method. Another frequent mistake is confusing the assignment operator equals with the comparison operator equals, which can lead to logical errors. Additionally, forgetting to use return for early exits can result in unexpected behavior, as the method might return the wrong value. Being mindful of these issues helps create more reliable and maintainable code. Methods are a cornerstone of Ruby programming, enhancing code reusability and modularity. Understanding how parameters are passed and how methods return values is critical for writing predictable and efficient code. Using default parameters, variable length arguments, and blocks can make your methods more versatile and expressive. Always consider the potential side effects of modifying mutable objects, as this can impact the rest of your program. By mastering these concepts, you can create cleaner, more maintainable code that is easier to understand and work with. Arrays in Ruby are ordered, indexed collections of objects. This means that each element in an array has a specific position, starting from 0. They allow you to store multiple values in a single variable, making it easier to manage groups of data. For example, you can store numbers, strings, or even other arrays within the same array. Since arrays are mutable, you can add, remove, or change elements after the array is created. This flexibility makes arrays a powerful tool for organizing and manipulating data in Ruby programs. Creating arrays in Ruby can be done using literal syntax, which is straightforward. For instance, writing array equals 1, 2, 3 creates an array containing the numbers 1, 2, and 3. Another method is the arrayNew function, which allows more control. For example, arrayNew 5, 0 generates an array with 5 elements, all set to 0. You can also combine elements by separating them with commas and enclosing them in brackets. This versatility lets you build arrays tailored to your specific needs, whether you want to initialize them with default values or populate them manually. Accessing elements in an array is done through indices, which are numerical positions starting from 0. So, array 0 retrieves the first element, array 1 gets the second, and so on. Ruby also supports negative indices, where array 1 returns the last element, array 2 the second last, and so forth. Additionally, you can use slicing to extract a range of elements. For example, array 1, 3 gives you elements starting at index 1 up to and including index 3. This feature is especially useful when working with large datasets or needing subsets of data for processing. Ruby arrays come with several methods for manipulation. The push method adds elements to the end of an array, while pop removes the last element. Shift is used to remove the first element, and unshift adds elements to the beginning. These methods allow you to dynamically modify arrays as your program runs. For instance, if you have a list of tasks, you can use push to add new tasks, shift to handle the oldest task first, or unshift to prioritize a new task at the top of the list. Understanding these methods helps in managing data efficiently. Array manipulation in Ruby includes sorting, reversing, deleting and checking for elements. The sort method arranges elements in ascending order, which is helpful for organizing data like grades or numerical values. Reverse flips the array, so the last element becomes the first. Delete removes the first occurrence of a specific element, while include checks if an element exists in the array. These methods provide powerful ways to modify and query arrays, making it easier to handle complex data structures in your programs. Iterating through arrays is essential for processing each element. The each method loops through every item, allowing you to perform actions like printing or modifying values. Map transforms elements by applying a block to each one, such as doubling numbers in a list. Select filters elements based on a condition, like finding all even numbers. Inject accumulates values, often used for summing elements or concatenating strings. These iteration techniques enable you to work with arrays in flexible and efficient ways, adapting to different programming tasks. Nested arrays allow you to create multi-dimensional structures by placing arrays within other arrays. For example, an array like 1, 2, 3, 4 contains 2 subarrays. Accessing elements in nested arrays requires chaining indices, such as array 0, 1 to get the second element of the first subarray. This structure is useful for representing grids, tables, or hierarchical data. Understanding nested arrays helps in managing complex data relationships, making it easier to work with matrices or layered information in your Ruby applications. Practical examples demonstrate how arrays are used in real-world scenarios. For instance, storing student grades in an array and sorting them helps in analyzing performance. Managing a to-do list with an array allows you to add tasks dynamically using push. Filtering data, such as selecting numbers greater than 5, showcases how arrays can process and refine information. These examples highlight the versatility of arrays in solving everyday programming challenges. From organizing data to performing calculations, arrays are a fundamental concept in Ruby, serving as a backbone for storing and managing collections of data. The language provides a rich set of methods to manipulate, iterate, and access arrays, making them highly adaptable. By practicing with arrays in various contexts, you can deepen your understanding and apply them effectively, exploring advanced techniques like zipping multiple. Arrays further expands their utility, offering new ways to handle complex data structures in your projects. Hashes are a fundamental data structure in Ruby that allow you to store and retrieve data using key-value pairs. Unlike arrays, which use numerical indexes to access elements, hashes use keys that can be any object, such as strings, symbols, or even numbers. This makes hashes incredibly versatile for organizing data in a way that is both intuitive and efficient. For example, you might use a hash to store user information where the keys are names like name or age, and the values are the corresponding details. Hashes are especially useful when you need to quickly look up data based on a specific identifier rather than a position in a list. They are often compared to dictionaries in other programming languages and are a core part of Ruby's design for handling structured data. Creating hashes in Ruby is straightforward and can be done using two primary syntaxes. The first is the modern symbol syntax, where you write key, value, key 2, value 2. This is clean and easy to read, especially when using symbols as keys. The second syntax uses the arrow operator, like key equals value, which is more traditional and allows for any object as a key, not just symbols. To create an empty hash, you can use hash new, which initializes a new hash with no key value pairs. For example, user equals name, Alice, age, 30, creates a hash with two key value pairs, where the keys are symbols and the values are strings and numbers. Understanding these syntaxes is essential for working with hashes in Ruby, as they provide flexibility depending on the use case. Accessing values in a hash is done by referencing the key associated with the value. You can use either the square bracket notation, like hash a key, or the string version, hash key, depending on the type of key you are using. However, using the square brackets can return nil if the key does not exist, which might lead to unexpected behavior. To avoid this, Ruby provides the fetch method, which allows you to retrieve a value safely. If the key is missing, fetch can optionally return a default value, making it a more robust choice for critical data. For instance, user age would return 30, but if you try to access a non-existent key like user gender, it would return nil unless you specify a default with fetch. This distinction is important for writing reliable code. Ruby hashes come with a variety of built-in methods to manipulate and analyze their contents. keys method returns an array of all the keys in the hash, which is useful for inspecting what data is stored. Similarly, values returns an array of all the values, allowing you to work with the data without the keys. The hash key method checks if a specific key exists in the hash, which is helpful for validating input or avoiding errors. The merge method combines two hashes into one, with the ability to override existing keys in the first hash with those from the second. For example, if you have two hashes, hash 1 equals A1 and hash 2 equals A2B3. Merging them would result in A2B3. These methods make it easy to work with hashes in complex applications. Iterating through a hash is a common task in Ruby, and the each method is the primary way to do this. With each, you can loop through each key value pair and perform actions on them. For example, hash each k v puts k v would print each key and value. If you only need to work with the keys or the values separately, you can use each key or each value respectively. These methods are particularly useful when you want to process only the keys or only the values without dealing with both. Iteration is a powerful tool for transforming or analyzing hash data, such as updating values or generating reports based on the stored information. Hashes in Ruby can contain other hashes or arrays, creating nested structures that allow for complex data organization. For example, a hash might store user data with another hash for the user's details and an array for their scores. This nesting is achieved by placing one hash or array as the value of another key. Accessing nested data requires chaining the keys, such as data, user, name to retrieve the name from the nested user hash. This capability is especially useful for representing real-world relationships, like a configuration file with multiple sections, or a database record with related fields. However, it's important to be cautious when working with nested structures to avoid errors from missing keys or unexpected data types. Hashes are widely used in practical applications to store and manage various types of data. For user data, a hash might look like id, one name, Charlie, where each key represents a specific attribute of the user. In configuration settings, hashes are ideal for storing options like debug, true port 3000, making it easy to access and modify settings. Hashes are also used for mapping relationships, such as apple equals fruit, carrot equals vegetable, which can act as a simple dictionary or lookup table. These examples illustrate how hashes provide a flexible and efficient way to structure data, making them a cornerstone of Ruby programming. When working with hashes, following best practices ensures clarity and reliability in your code. Using symbols as keys is recommended because they are more efficient and readable than strings, especially in large applications. Avoiding mutable keys, such as arrays or other hashes, prevents unexpected behavior since their contents can change, leading to inconsistencies. Instead of relying on to access values, which can return nil, prefer the fetch method to handle missing keys gracefully. These practices help maintain clean, predictable code and reduce the risk of bugs, making your hash-based logic more robust and easier to debug. Conclusion: hashes are a critical component of Ruby programming, offering a powerful way to store and manage structured data. Understanding how to create, access, and manipulate hashes is essential for any Ruby developer. By mastering key value access, iteration, and nested structures, you can build more efficient and maintainable applications. Practicing methods like merge and fetch will further enhance your ability to work with complex data, ensuring your code is both effective and elegant. As you continue learning Ruby, hashes will become an indispensable tool in your toolkit. Strings in Ruby represent sequences of characters that are used to store and manipulate text. One important characteristic of strings in Ruby is that they are immutable, which means once a string is created, its content cannot be changed. This immutability ensures that the original string remains unchanged, which can help prevent unintended side effects in your code. To create a string, you can use either single quotes or double quotes. For example, name equals Ruby or greeting equals hello. Single quotes are typically used when you don't need to interpolate variables or expressions, while double quotes allow for interpolation using the hash and bracket syntax. Understanding the difference between these two is essential for writing efficient and readable Ruby code. String concatenation in Ruby can be achieved using the plus operator or the shovel operator. The plus operator combines two strings and returns a new string, which is useful when you want to keep the original strings unchanged. For example, full name John plus Doe creates a new string, John Doe. The shovel operator, on the other hand, appends the second string to the first one, modifying the original string. So message equals hello plus world creates hello world, while message equals hello world appends world to the existing message string. This distinction is important because the shovel operator can be more efficient in certain scenarios, especially when working with large strings. String interpolation in Ruby allows you to embed variables or expressions directly within a string using the hash and bracket syntax. This feature is particularly useful when you need to dynamically construct strings based on variable values. For instance, if you have a variable name equals Ruby, you can write puts welcome name to produce the output welcome Ruby. Interpolation works only with double-quoted strings, so it's important to choose the appropriate quotation mark based on your needs. This technique simplifies the process of building complex strings and makes your code more readable and maintainable. Ruby provides several common string methods to help you work with strings more effectively. The length method returns the number of characters in a string, which is useful for validating input or determining the size of a string. The empty method checks whether a string is empty, returning true or false. The include method allows you to check if a specific substring exists within a string, which is helpful for searching or filtering data. Additionally, the upcase and downcase methods convert all characters in a string to uppercase or lowercase, respectively. These methods are frequently used in tasks such as data processing, user input validation, and text formatting. Case conversion methods in Ruby are essential for manipulating the capitalization of strings. The upcase method converts all characters in a string to uppercase, while the downcase method does the opposite, converting them to lowercase. The capitalize method is particularly useful for ensuring that the first character of a string is uppercase, while the rest remain lowercase. For example, Ruby upcase becomes Ruby, and hello capitalize becomes hello. These methods are commonly used in scenarios such as formatting user input, generating titles, or preparing data for display. Understanding how to apply these methods can help you create more consistent and user-friendly applications. Splitting and joining strings in Ruby allows you to transform strings into arrays and vice versa. The split method takes a separator as an argument and divides a string into an array of substrings. For instance, a BC split produces a BC, which is useful for parsing data from comma-separated values. Conversely, the join method combines elements of an array into a single string with the option to specify a separator. For example, X, Y, Z join results in XYZ, which is helpful for generating formatted output or constructing URLs. These methods are powerful tools for handling structured data and improving the flexibility of your string manipulation tasks. Accessing characters and substrings in Ruby can be done using the square bracket notation. By providing an index, you can retrieve a specific character from a string, such as Ruby 0 returning R. This is particularly useful for extracting individual characters or analyzing the structure of a string. Additionally, you can use ranges to extract substrings. For example, Ruby 1.3 returns UB, which includes characters starting at index 1 up to and including index 3. This method of indexing and substring extraction is essential for tasks such as parsing text, validating input, or modifying specific parts of a string. Comparing strings in Ruby involves several operators and methods. The equality operator equals checks if two strings are identical, returning true or false. The triple equals operator equals is often used in case statements for pattern matching. The casefold method, however, allows for case-insensitive comparisons, making it ideal for scenarios where case differences should be ignored. For example, Ruby equals Ruby returns false, but Ruby casefold Ruby returns 0, indicating a match. These comparison techniques are crucial for handling user input, validating data, or implementing conditional logic based on string values. Ruby offers a variety of string manipulation methods to modify and transform strings. The gsub method replaces all occurrences of a pattern in a string with a specified replacement, making it useful for tasks like correcting typos or formatting text. The strip, lstrip, and rstrip methods remove white space from the beginning, end, or both ends of a string, respectively. For example, Ruby strip becomes Ruby. The reverse method returns a new string with the characters in the opposite order, which can be handy for creating palindromes or analyzing string structure. These methods are invaluable for cleaning data, preparing text for processing, or enhancing user experience through dynamic content generation. Strings are a fundamental aspect of Ruby programming, serving as the primary means of handling text in applications. Methods such as concatenation, interpolation, splitting, and case conversion significantly enhance the ability to manipulate strings, making your code more efficient and readable. Understanding the immutability of strings and the various methods available ensures that you can handle text data effectively in real-world scenarios. Practicing these techniques through hands-on examples and projects will help solidify your understanding and improve your ability to solve complex problems using Ruby. File input-output operations are fundamental to programming as they allow data to be stored, retrieved, and manipulated through files. Ruby provides a powerful set of tools to handle these tasks, including the file and I/O classes. These classes offer methods to perform essential actions like opening a file, reading its contents, writing new data, and closing the file when the operation is complete. Understanding these operations is crucial for building applications that interact with external data sources or persist information beyond the runtime of a program. Reading from files in Ruby can be done in multiple ways depending on the use case. The file read method is ideal for loading an entire file into memory as a single string, which is useful for small files or when the entire content is needed at once. For larger files or when processing line by line, the file for each method is more efficient. It iterates through each line of the file, allowing you to handle data incrementally without consuming excessive memory. For example, reading a text file named data, txt with file read returns all its content as a string, while file for each processes each line individually. Writing to files in Ruby requires opening the file in the appropriate mode. The W mode is used to create a new file or overwrite an existing one. When using file open with this mode, you can write data using methods like puts or print. The example provided demonstrates how to write hello Ruby to a file called output.txt. The block ensures that the file is automatically closed after the operation, preventing resource leaks. This approach is safer and more concise than manually closing the file, which is essential for maintaining clean and reliable code. Ruby file modes determine how a file is accessed and modified. The R mode is for reading only and is the default if no mode is specified. The W mode allows writing and creates a new file or truncates an existing one. The mode appends data to the end of a file without erasing its existing content. For scenarios requiring both reading and writing, modes like R, W+, and A+ are available. Choosing the correct mode is critical to avoid unintended data loss or access issues, especially when working with existing files. Handling exceptions is a vital part of robust file I/O operations. When a file is missing or inaccessible, Ruby raises exceptions like errno, a note for file not found errors. Using begin rescue blocks allows you to catch these errors and respond gracefully. For instance, if a program attempts to read a non-existent file, the rescue block can display a message like file not found instead of crashing. This practice ensures that your application can handle unexpected situations and provide meaningful feedback to users. Using blocks in Ruby for file handling is a best practice that ensures files are properly closed after use. When you open a file within a block, Ruby automatically closes it, even if an error occurs during the operation. This eliminates the need for explicit close calls and reduces the risk of resource leaks. The example demonstrates how to read a file's content using a block, making the code more concise and reliable. Blocks also promote cleaner code by encapsulating file operations within a controlled scope. Reading and writing binary files requires specific modes like RB for reading and WB for writing. These modes are essential for handling non-text data such as images, audio files, or compiled programs. Ruby provides methods like read partial and write to manage binary data efficiently. When working with text files, ensuring the correct encoding is crucial to prevent data corruption. For example, using RB ensures that the file is read in binary mode without any character encoding transformations, preserving the original data structure. Advanced I/O techniques in Ruby include using string I/O for in-memory operations and popen for interacting with external processes. String I/O allows you to treat a string as a file, which is useful for testing or manipulating data without accessing the file system. Popen enables communication with external commands, such as running a shell script or executing a system command. For instance, popen ls captures the output of the ls command reads it into Ruby, demonstrating how I/O can bridge the gap between your program and the operating system. Following best practices for file I/O ensures your code is reliable and maintainable. Always close files after use, which can be done automatically with blocks. Before performing read or write operations, validate that the file exists to avoid errors. Choose the appropriate mode to prevent accidental data loss, such as using A for appending instead of W for overwriting. Handling exceptions is also critical to prevent crashes and provide clear error messages. These practices collectively contribute to writing robust and efficient Ruby programs that handle I/O operations gracefully. File I/O is a cornerstone of programming, enabling applications to store and retrieve data effectively. Ruby's file and I/O classes provide a flexible and powerful framework for these tasks, making it easier to manage files of varying sizes and types. By mastering techniques like blocks, modes, and exception handling, you can build reliable applications that interact seamlessly with external data. Practicing these concepts will deepen your understanding and improve your ability to solve real-world programming challenges. Exceptions are events that disrupt the normal flow of a program. When something goes wrong during the execution of code, Ruby uses exceptions to handle these errors instead of letting the program crash abruptly. For example, if a user inputs invalid data, a file is missing, or a division by 0 occurs, Ruby can catch these issues and respond appropriately. This helps maintain the stability of the application. The exception handling system in Ruby is built on a hierarchy of classes, with the base class being exception. Understanding this hierarchy is key to managing errors effectively in your code. All exceptions in Ruby trace back to the exception class, which serves as the foundation for all error handling mechanisms. Below this, there are several important subclasses. The standard error class, for instance, includes common runtime errors like argument error, which occurs when a method is called with incorrect parameters, or no method error, which happens when a method is called on an object that doesn't recognize it. Then there is script error, which covers issues related to the code itself, such as syntax error when there's a typo, or load error when a file can't be loaded. System-level errors are handled by classes like system exit, which is used to terminate a program. and signal exception, which deals with external signals like keyboard interrupts. To handle exceptions in Ruby, you use the begin and rescue keywords. The begin block contains the code that might raise an error, while the rescue block catches the exception and handles it. For example, if you're trying to open a file and it's not found, the rescue block can display a message instead of letting the program crash. You can rescue specific exceptions, like standard error, which covers most runtime errors, or you can rescue more general exceptions. However, it's best practice to be as specific as possible when rescuing to avoid accidentally catching unexpected errors. This ensures your program responds to issues in a controlled and predictable way. The ensure keyword guarantees that a block of code runs no matter what happens in the surrounding code. This is particularly useful for cleanup tasks, such as closing files or releasing resources. For instance, if you open a file in a begin block, you can use ensure to make sure it's closed even if an error occurs. Unlike rescue, which handles exceptions, ensure executes regardless of whether an exception was raised. This makes it ideal for maintaining the integrity of your program's resources, ensuring that critical operations are always completed. Ruby allows you to raise exceptions manually using the raise keyword. This is useful when you want to trigger an error condition explicitly, such as when validating user input. For example, if a function requires a parameter and it's missing, you can raise an argument error with a descriptive message. You can also raise specific exceptions by specifying the class and message, like raise argument error, missing parameter. This helps create more meaningful error messages and allows other parts of the program to handle the exception appropriately. Raising exceptions is a powerful tool for controlling the flow of your code and signaling problems in a clear way. Creating custom exceptions in Ruby is straightforward and allows you to define error types that are specific to your application's needs. To do this, you inherit from the exception class and give your new class a name that reflects the type of error it represents. For example, a custom exception like myCustomError can be used to handle domain-specific issues, such as invalid data formats or business rule violations. By using custom exceptions, you can make your error handling more precise and readable, which improves the maintainability of your code. This approach also helps distinguish between different types of errors in your application. When handling exceptions, there are several best practices to follow. First, always rescue specific exceptions rather than using a general rescue block, as this prevents unintended errors from being caught. Avoid leaving rescue blocks empty. Even if you're not handling an error, you should at least log it for debugging. Logging exceptions is crucial for identifying and fixing issues in production environments. Use ensure for cleanup tasks, not rescue, to ensure resources are released properly. Finally, make sure error messages are clear and descriptive so that anyone reading them can quickly understand the problem. These practices lead to more robust and maintainable code. Exceptions are a vital part of writing reliable Ruby programs. By using rescue, ensure, and raise, you can control the flow of your code and handle errors gracefully. This not only improves the user experience, but also makes your application more resilient to unexpected situations. Custom exceptions allow you to create domain-specific error handling, while proper logging helps with debugging and monitoring. Combining these techniques ensures your code is both robust and easy to maintain. Mastering exception handling is an essential skill for any Ruby developer. Object-oriented programming is a programming paradigm that revolves around the concept of objects and classes. These objects represent real-world entities, and classes act as blueprints for creating these objects. The four key principles that define this approach are encapsulation, inheritance, polymorphism, and abstraction. Encapsulation involves bundling data and methods into a single unit while controlling access to the internal state. Inheritance allows a class to inherit properties and behaviors from another class, promoting code reuse. Polymorphism enables objects of different classes to be treated as objects of a common superclass, allowing for flexible and dynamic code. Abstraction focuses on simplifying complex systems by hiding unnecessary details and exposing only essential features. This approach helps in creating modular, scalable, and maintainable code. By modeling real-world scenarios into structured code elements. In Ruby, a class serves as a blueprint that defines the structure and behavior of objects. When you create a class, you are essentially defining a template that can be used to generate multiple instances. An object is an instance of a class, meaning it is a specific realization of the class blueprint. For example, if you define a class called dog, you can create multiple objects from it, each representing a different dog. The syntax for creating a class is straightforward, such as using the keyword class followed by the class name. To create an object, you use the new method on the class. This process is fundamental to object-oriented programming, as it allows for the creation of reusable and consistent code structures. Encapsulation is a core concept in object-oriented programming that involves bundling data and methods into a single unit, typically a class. This helps in organizing code and managing the internal state of objects. In Ruby, encapsulation is achieved through accessors such as a trackcessor, a treater, and a triter. These methods allow you to control how attributes of an object are accessed and modified. For instance, a trackcessor name creates both a getter and a setter method for the name attribute, enabling you to read and write the value. This approach ensures that the internal state of an object remains protected, while still allowing controlled interaction with its properties. Encapsulation enhances code maintainability and reduces the risk of unintended side effects. Inheritance is a mechanism in object-oriented programming that allows a class to inherit properties and methods from another class. This promotes code reuse and establishes a hierarchical relationship between classes. In Ruby, inheritance is implemented using the less than symbol followed by the parent class name. For example, a class poodle that inherits from a class dog would automatically have access to all the methods and attributes defined in the dog class. Ruby also supports modules, which can be included in classes to add shared behavior. The super keyword is used to call methods from the parent class, ensuring that the inherited functionality is properly utilized. This feature allows for the creation of specialized classes that build upon existing ones, enhancing code efficiency and organization. Polymorphism is a principle that allows objects of different classes to be treated as objects of a common superclass. This is achieved through method overriding, where a subclass provides a specific implementation of a method defined in its superclass. Ruby supports dynamic binding, which means that the appropriate method is determined at runtime based on the object's actual class. For example, both a dog and a cat class can have a speak method, but each will produce a different output. This flexibility enables code to be written in a way that is not tied to specific classes, making it more adaptable and easier to extend. Polymorphism is essential for creating systems that can handle a variety of objects in a uniform manner. Ruby's object model is unique in that everything in the language is an object, including primitive types like integers and strings. This means that even basic values such as 5 or hello are instances of classes. Classes themselves are objects of the class, which adds a layer of flexibility to the language. Modules play a crucial role in Ruby by providing a way to share behavior across multiple classes through mixins. Unlike traditional inheritance, modules allow for the inclusion of methods without the limitations of a single inheritance hierarchy. This design makes Ruby highly modular and encourages the reuse of code. Understanding this object model is essential for leveraging Ruby's full potential and creating efficient, maintainable code. Mastering object-oriented programming in Ruby is essential for building scalable and maintainable applications. The concepts of classes, objects, inheritance, and encapsulation form the foundation of this approach, enabling developers to create structured and reusable code. By understanding how to model real-world entities as code structures, you can design systems that are both flexible and efficient. Practice is key to solidifying these concepts, so experimenting with simple examples and gradually tackling more complex scenarios will help reinforce your understanding. As you progress, you will find that these principles are not only fundamental to Ruby, but also widely applicable across various programming paradigms. Embrace the learning process and continue exploring how OOP can enhance your coding practices. Classes in Ruby serve as blueprints for creating objects, allowing developers to define the structure and behavior of their programs. These blueprints contain properties, which are the data an object holds, and behaviors, which are the actions an object can perform. Ruby is a pure object-oriented language, meaning every element in the language is an object, including numbers, strings, and even classes themselves. This design encourages encapsulation, where data and the methods that operate on that data are bundled together within a class, promoting modularity and easier maintenance. By organizing code into classes, developers can create reusable and manageable code structures. To define a class in Ruby, you use the class keyword followed by the class name, which should follow the Pascal case convention. For example, the class dog in this example includes a method called bark that outputs woof when called. This structure allows developers to create a template for objects where each instance of the class can have its own unique data while sharing the same methods. The syntax is straightforward, with the class body enclosed in the class and end keywords. This approach makes it easy to create and manage objects with consistent behavior. Creating objects from a class is done using the new method, which instantiates a new object. For instance, myDog equals dogNew creates a new instance of the dog class, and calling myDog bark executes the bark method. When an object is created, Ruby automatically invokes the initialize method, which is used to set up the initial state of the object. This makes it possible to pass arguments during object creation, allowing each instance to have unique properties. The initialize method acts as a constructor, ensuring that objects are properly initialized with the necessary data. Instance variables, denoted by the @ symbol, are used to store data specific to each object. For example, in the cat class, the initialize method assigns the name parameter to the @name instance variable. Methods like greet then access this variable to perform actions, such as printing a greeting. This approach ensures that each cat object maintains its own data, separate from other instances. By using instance variables, developers can create objects with unique characteristics while maintaining a consistent interface for interacting with those objects. In Ruby, methods can be either instance methods or class methods. Instance methods operate on specific objects and have access to the object's data through instance variables. For example, the add method in the mathutils class is a class method defined using self. This means it can be called directly on the class itself, rather than on an instance. Class methods are useful for utility functions that don't require an object state, such as mathematical operations. Understanding the difference between these two types of methods helps developers structure their code effectively. Ruby provides a convenient way to generate getters and setters for instance variables using a trackcessor. This shorthand creates both a reader and a writer method, allowing objects to access and modify their data. For example, the person class uses a trackcessor name to automatically create methods for reading and writing the @name variable. This simplifies code by eliminating the need to manually define these methods while still maintaining encapsulation. Developers can also use a treater and a triter individually for more controlled access to an object's data. Inheritance in Ruby allows classes to inherit properties and methods from other classes, promoting code reuse and a hierarchical structure. The syntax for inheritance uses the less than symbol, as seen in the dog class inheriting from the animal class. This means that dog objects can access the methods defined in animal, such as speak, unless they override them. Inheritance helps create a logical relationship between classes, where a subclass can extend or modify the behavior of its superclass, making it easier to manage complex systems. Polymorphism in Ruby allows subclasses to override methods from their parent classes, enabling different behaviors for the same method name. For example, the bird class defines a fly method, but the penguin subclass overrides it to return cannot fly. This means that when the fly method is called on a penguin object, it behaves differently than when called on a bird object. Polymorphism enhances flexibility, allowing developers to write code that works with objects of different types while maintaining a consistent interface. Best practices for designing classes include keeping them focused on a single responsibility, which makes them easier to understand and maintain. Using a treater or a triter instead of exposing instance variables directly provides controlled access to an object's data. Avoiding overly complex hierarchies prevents code from becoming difficult to navigate and reduces the risk of unintended side effects. By following these principles, developers can create clean, efficient, and scalable Ruby applications. In conclusion, classes in Ruby define the structure of objects, allowing developers to create reusable and organized code. Instantiation brings these classes to life by creating specific instances with unique data. Methods, attributes, and inheritance are essential tools for building robust applications. By practicing the design of classes for real-world scenarios, such as modeling a library system or a game, developers can strengthen their understanding of object-oriented programming and improve their ability to solve complex problems. Instance variables are a fundamental concept in Ruby programming. They are unique to each object of a class meaning every instance of a class has its own set of instance variables. This allows different objects to hold different data even if they belong to the same class. Instance variables start with the @ symbol, which is written as @ followed by a name such as @name or @age. These variables store data that is specific to a particular instance, like the age of a person or the color of a car. For example, in a person class, an instance variable at age could be set to 25 for one object and 30 for another. This distinction is crucial because it ensures that each object maintains its own state, separate from other objects of the same class. Declaring instance variables occurs within a class, but outside of methods. This means they are defined at the class level, not inside any specific method. Once declared, they become accessible to all methods within that class, allowing different methods to share and manipulate the same data. For instance, in a car class, the initialize method is often used to set up instance variables. The code example shows how the @color instance variable is assigned a value when a new car object is created. This setup ensures that every car instance starts with a specific color, and any method within the car class can access or modify this color as needed. Declaring variables at the class level also helps in organizing code and making it more readable. Accessing instance variables within methods is done using the self keyword, which refers to the current object. This allows methods to interact with the data stored in instance variables. For example, the displayColor method in the car class uses @color to output the car's color. However, it is important to avoid direct access to instance variables from outside the class. Encapsulation, a core principle of object-oriented programming, ensures that data is hidden and accessed only through defined methods. This practice protects the integrity of the data by preventing unintended modifications. By using methods to retrieve or update instance variables, developers can control how data is used and ensure consistency across the application. Methods in Ruby are blocks of code that perform specific tasks. They are defined using the def keyword followed by the method name and the end keyword to close the method. Methods allow programmers to organize code into reusable components, making the code more modular and easier to maintain. For example, a greet method can be created to print a greeting message. When this method is called, it executes the code inside its block, which in this case is simply outputting hello to the console. Methods can be as simple or complex as needed, and they are essential for creating dynamic and flexible programs. Method parameters allow data to be passed into methods, enabling them to perform actions based on the input provided. In Ruby, parameters are listed within parentheses after the method name, and they can be used within the method's block. Return values are the results that a method produces, which can be explicitly returned using the return keyword, or implicitly when the last line of the method is evaluated. For instance, the add method takes two parameters, a and b, and returns their sum. This flexibility allows methods to process data and provide output that can be used elsewhere in the program. Understanding how to pass and return data is essential for building interactive and responsive applications. Instance methods are methods that operate on instance variables, allowing them to interact with the data specific to each object. These methods are defined within a class and can access the instance variables of that class. For example, the person class has an initialize method that sets the @name instance variable, and an introduce method that uses this variable to print a greeting. This relationship between instance methods and instance variables is central to object-oriented programming, as it enables objects to have both data and behavior. By encapsulating data and methods within a class, developers can create self-contained units of functionality that are easy to manage and extend. Modifying instance variables requires careful handling to maintain data integrity. Instead of allowing direct access to instance variables, it is best to use setter methods, which provide a controlled way to update the data. For example, the setName method in the person class allows the @name instance variable to be changed while ensuring that any necessary validation or logic is applied. This approach prevents unintended modifications and makes the code more robust. By using setter methods, developers can enforce rules about how data is updated, such as checking for valid input or triggering other actions when a value changes. This practice enhances the reliability and maintainability of the code base. Common mistakes when working with instance variables include forgetting the symbol, which leads to the creation of local variables instead of instance variables. This can result in unexpected behavior, as local variables are not retained between method calls. Another mistake is using local variables instead of instance variables, which limits the scope of the data and makes it inaccessible to other methods. Additionally, not encapsulating data properly by allowing direct access to instance variables can lead to bugs and make the code harder to maintain. These errors highlight the importance of understanding the distinction between local, instance, and class variables, and adhering to best practices for data management. Following best practices when working with instance variables and methods is essential for writing clean and maintainable code. Using descriptive names for instance variables, such as at full name instead of at n, improves readability and makes the code easier to understand. Keeping methods focused on a single responsibility ensures that each method has a clear purpose, which simplifies debugging and testing. Additionally, using accessors like a treater and a writer provides controlled access to instance variables without exposing them directly. These practices not only enhance code quality, but also make it easier for other developers to work with the code in the future. In summary, instance variables are essential for storing object-specific data, while methods define the behavior of a class. Together, they form the foundation of object-oriented programming in Ruby, allowing developers to create flexible and reusable code. Proper encapsulation ensures that data remains protected and is accessed only through well-defined methods, which enhances the reliability and maintainability of the application. By understanding and applying these concepts, programmers can build robust and scalable software solutions that meet the needs of their users. Class variables and constants are essential tools for structuring and managing data within Ruby classes. They allow developers to create shared state across multiple instances of a class and to define values that should remain consistent throughout the program's execution. Class variables are particularly useful when you need to track information that is common to all instances, such as a counter for how many times a method has been called. Constants, on the other hand, are ideal for values that are intended to be fixed, like configuration settings or mathematical values. By using these features, you can write more organized and maintainable code. Class variables are defined using the double at symbol prefix, such as at counter. This naming convention indicates that the variable belongs to the class itself rather than to any individual instance. Because class variables are shared among all instances of a class and its subclasses, they can be accessed and modified by any method within the class hierarchy. For example, in a counter class, a class variable named count could track how many times the increment method has been called. However, this shared nature means that changes to a class variable affect every instance, which can lead to unexpected behavior if not carefully managed. Class constants are defined using uppercase letters, such as MAXUSERS. By convention, they are meant to represent values that should not change during the program's execution. While Ruby does not enforce immutability for constants, it is considered best practice to treat them as fixed. For instance, a config class might define a constant MAXUSERS to limit the number of users allowed in an application. Constants are scoped to the class in which they are defined, making them easier to reference and less likely to conflict with other variables in the program. Class variables are best suited for scenarios where data needs to be shared across all instances of a class, such as maintaining a running total or a configuration value that applies globally. For example, a class might use a class variable to track the number of objects created. Constants, meanwhile, are ideal for values that should remain unchanged, such as a maximum limit or a fixed identifier. It is important to avoid modifying constants once they are defined, as this can lead to confusion and errors in the code. By using these features appropriately, you can create more predictable and readable programs. Class variables and constants differ in several key ways. Class variables are mutable, meaning their values can be changed after they are defined, and they are accessible to all instances of a class and its subclasses. They are typically accessed using the self-class method to ensure the correct class context. Constants, on the other hand, are generally intended to be immutable, though Ruby allows them to be redefined. They are scoped to the class in which they are defined and are accessed using the class name followed by a double colon and the constant name. Understanding these differences helps you choose the right tool for the task at hand. When working with class variables, it is crucial to use them with caution, as their shared nature can lead to unintended side effects. For example, modifying a class variable in one part of the code may inadvertently affect other parts of the program. To avoid this, always consider whether a class variable is truly necessary. Instead, prefer constants for values that should not change during runtime, as they provide a clearer and more stable reference point. When accessing class variables within class methods, use self-class to ensure you are interacting with the correct class, especially in inheritance scenarios. These practices help maintain clean and predictable code. In conclusion, class variables and constants play a vital role in structuring and managing data in Ruby. They provide a way to share state across instances and define fixed values that enhance code clarity. Understanding their scope, mutability, and appropriate use cases is essential for writing efficient and maintainable programs. By following best practices, such as using class variables sparingly and treating constants as immutable, you can ensure your Ruby code remains clean, predictable, and easy to work with. Inheritance is a fundamental concept in object-oriented programming that allows classes to inherit properties and methods from other classes. This means that a class can share code with another class, reducing redundancy and promoting efficiency. Ruby specifically uses single inheritance, which means that a class can only inherit from one direct superclass. This approach simplifies the class hierarchy and avoids the complexities that come with multiple inheritance. By establishing a clear hierarchical relationship between classes, inheritance helps organize code in a logical and maintainable way. For example, a subclass can build upon the functionality of a superclass, making it easier to manage and extend code over time. To create a subclass in Ruby, you use the syntax class child parent. The parent class is referred to as the superclass, while the child class is the subclass. This relationship means that the subclass automatically inherits all the methods and variables defined in the superclass. For instance, if the superclass has a method called display, the subclass can use that method without redefining it. This inheritance mechanism allows for code reuse, as common functionality can be centralized in a superclass and shared across multiple subclasses. It also enables the creation of specialized classes that can add new features or modify existing ones while retaining the core behavior of their parent class. One of the key features of inheritance is method overriding, which allows a subclass to redefine a method from its superclass. This is useful when you want to modify or extend the behavior of a method to suit the needs of the subclass. For example, if a superclass has a method called calculate, a subclass can override it to provide a different implementation. However, it's important to note that overriding a method doesn't eliminate the original functionality. Instead, you can use the super keyword to call the superclass's version of the method. This ensures that the original behavior is preserved while allowing the subclass to add its own logic. The syntax for this is simple. Def method super end, which invokes the parent class's method. The super keyword plays a crucial role in managing method calls between classes. When used within a method, it invokes the method of the immediate superclass, allowing the subclass to build upon the existing functionality. This is particularly useful when you want to extend or modify the behavior of a superclass without completely replacing it. For example, a subclass might add additional steps to a method while still relying on the superclass's implementation. The super keyword must always be called within a method definition, as it cannot be used outside of a method context. This ensures that the code remains structured and that method calls are properly scoped to the appropriate class. At the core of Ruby's class hierarchy is the object class, which serves as the root for all other classes. Every class in Ruby implicitly inherits from object, even if it's not explicitly stated. This means that all objects in Ruby have access to the methods defined in the object class, such as to's, inspect, and equal. These methods provide basic functionality for converting objects to strings, inspecting their contents, and comparing objects for equality. For example, when you create a class like myClass, it automatically inherits from object, making these methods available without any additional code. This design ensures consistency across all objects and provides a foundation for more specialized classes. Ruby's inheritance model follows a linear hierarchy, meaning that each class has exactly one direct superclass. This structure avoids the potential confusion and conflicts that can arise with multiple inheritance. To explore a class's inheritance chain, Ruby provides two useful methods: superclass and ancestors. The superclass method returns the immediate parent of a class, while the ancestors method lists all the classes in the hierarchy, including the superclass, its superclass, and so on. This allows developers instructors to understand the full lineage of a class and troubleshoot any issues related to method resolution. For instance, if a method is not behaving as expected, checking the ancestors list can reveal where the method is defined and how it interacts with other classes. Understanding the relationship between a subclass and its superclass is essential for effective Ruby programming. Subclasses can access and modify the behavior of their superclass, which allows for flexible and dynamic code. However, this power comes with responsibility. Proper use of the super keyword ensures that the superclass's methods are called correctly, maintaining consistency across the hierarchy. It's also important to avoid deep inheritance chains, as they can make code harder to read and maintain. A deep hierarchy can lead to unexpected behavior and make it difficult to trace where a particular method or variable originates. By keeping inheritance relationships simple and focused, developers can create more robust and maintainable code. In summary, inheritance in Ruby is a powerful tool for promoting code reuse and organizing classes in a hierarchical structure. By allowing classes to inherit from a single superclass, Ruby simplifies the design of complex applications while maintaining clarity. The super keyword is essential for managing interactions between classes, ensuring that superclass methods are called when needed. Understanding the relationships between classes and their superclasses is critical for building reliable and scalable Ruby programs. As you continue to explore Ruby, remember that inheritance should be used thoughtfully, with an emphasis on simplicity and maintainability. With these principles in mind, you can create efficient and well-structured code that stands the test of time. Modules in Ruby are a powerful way to group related methods, classes, and constants together. This organization helps keep your code structured and manageable. One of the key purposes of modules is to act as namespaces. Think of a namespace as a container that prevents naming conflicts. For example, if two different libraries have a method called add, using modules ensures that these methods don't clash. Modules can also be included in classes to share functionality. This means you can define a set of methods in a module and then bring them into any class that needs them. Unlike classes, modules cannot be instantiated. They serve as a way to encapsulate behavior that can be reused across multiple classes without the need for inheritance. Defining a module in Ruby is straightforward. The syntax starts with the keyword module followed by the module name and ends with end. For example, module math utils end. Inside the module, you can define methods, constants, and even nested modules. Let me show you an example. Here, we have a module called math utils with a method called add. This method is defined using self-add, which makes it a class-level method within the module. So when you call math utils, add 2, 3, it returns 5. Modules can also contain constants, such as pi, which can be accessed using math utils, pi. Additionally, you can nest modules inside other modules to create a hierarchical structure, which is useful for organizing large code bases. Including a module in a class is done using the include keyword. This allows the methods defined in the module to become instance methods of the class. For example, if we have a class called calculator and we include math utils, all the methods in math utils become available as methods of calculator instances. This is a form of code reuse that avoids the limitations of single inheritance. By including a module, you can add functionality to a class without having to inherit from another class. This makes your code more flexible and easier to maintain. It's important to note that the methods added by include are instance methods, meaning they operate on instances of the class rather than the class itself. Mix-ins are a specific type of module that are used to add behavior to classes. They are a cornerstone of Ruby's approach to code reuse. Since Ruby only supports single inheritance, mix-ins provide a way to include multiple sets of methods into a class. This is different from traditional inheritance, where a class can only inherit from one parent class. Mix-ins allow you to share functionality across classes without the complexity of multiple inheritance. For instance, a module that provides logging capabilities can be included in any class that needs to log messages. This makes your code more modular and easier to test. Mix-ins are particularly useful for adding cross-cutting concerns, such as authentication or serialization, to multiple classes without duplicating code. When a module is included in a class, its methods are added to the class's method lookup path. This means that when you call a method on an instance of the class, Ruby checks the class itself first, then any included modules. The order in which modules are included affects the method lookup. If two modules define the same method, the one included last takes precedence. For example, if you include module A and then module B, and both have a method called log. The log method from module B will be used. This behavior allows you to override methods from earlier included modules, giving you control over which implementation is used. Understanding this order is crucial for avoiding unexpected behavior when using multiple mixins. Modules and classes serve different purposes in Ruby. While classes can be instantiated and can inherit from other classes, modules cannot be instantiated. This makes modules ideal for encapsulating shared functionality that doesn't need to be tied to a specific instance. For example, a module might contain methods for validating user input, which can be included in multiple classes. Classes, on the other hand, are used to create objects and define their behavior through inheritance. Modules are often used for utility functions, such as logging or data processing, that are needed across different parts of an application. By using modules, you can keep your code organized and reduce duplication. Let me demonstrate how a mixin works with a practical example. Here, we have a module called logging with a method called log. This method outputs a message to the console. Now, consider a class called user. By including the logging module, the user class gains access to the log method. This means that any instance of user can call log user created to record a message. This approach is much cleaner than duplicating the log method in every class that needs it. Mixins like this are commonly used in Ruby to add functionality such as logging, caching, or error handling to multiple classes without the need for inheritance. This makes your code more maintainable and easier to extend. When using modules and mixins, there are some best practices to keep in mind. First, use modules for cross-cutting concerns, features that affect multiple parts of your application, such as authentication, logging, or serialization. This helps keep your code organized and reduces duplication. Avoid overloading modules with too many unrelated methods, as this can make them harder to maintain. Instead, keep modules focused on a single responsibility. Another tip is to use extend when you want to add module methods as class methods rather than instance methods. For example, if you have a module with a method that should be called on the class itself, use extend instead of include. This gives you more flexibility in how you use your modules. In summary, modules are a fundamental part of Ruby that help organize code and prevent naming conflicts. They allow you to encapsulate functionality that can be reused across multiple classes through mixins. Mixins enable flexible code reuse without the limitations of single inheritance, making your code more modular and maintainable. By mastering modules and mixins, you can write cleaner, more efficient Ruby code that is easier to test and extend. Whether you're adding logging, validation, or other shared behaviors, modules provide a powerful tool for building scalable applications. Remember to use them wisely, keeping your code organized and focused on its intended purpose. RSpec is a behavior-driven development framework for the Ruby programming language. This approach focuses on writing tests that describe the expected behavior of your code rather than just verifying its correctness. By emphasizing clear, human-readable test cases, RSpec helps developers and stakeholders align on what the code should do. This practice not only improves code quality by catching bugs early, but also enhances maintainability by making the code base more predictable and easier to modify. RSpec is particularly popular in Ruby on Rails projects, where it streamlines testing for models, controllers, and other components, ensuring robust and reliable applications. To install RSpec, begin by adding the gem to your project's gemfile. This ensures the framework is included in your dependencies. Once added, run the bundle install command to download and install all required gems. Next, use the RSpec init command to generate the necessary configuration files and directories, such as a spec folder and an RSpec configuration file. This setup allows you to organize your tests systematically. Finally, verify that RSpec is available by checking the project directory for the generated files, ensuring it is ready for use in your development workflow. Writing RSpec tests involves structuring your tests using describe and it blocks. The describe block groups related tests, while the it block defines individual test cases. For example, a describe block might cover a calculator class, and an it block could test its add method. Assertions in RSpec are made using the expect syntax, which is more expressive than traditional assertion methods. The example provided demonstrates a simple test where 2 plus 2 is expected to equal 4. This syntax makes tests more readable and easier to understand, allowing developers to focus on the behavior being tested rather than the mechanics of the assertions. When writing test cases, focus on individual methods or classes to ensure clarity and precision. For instance, testing a user class might involve checking if a user's name is correctly assigned. This example creates a user with the name Alice and verifies that the name property matches. Beyond basic functionality, tests should also cover edge cases, such as invalid inputs or unexpected scenarios. For example, a test might check how the user class handles an empty name or a name with special characters. By addressing these situations, you ensure your code is resilient and behaves as intended under various conditions. RSpec provides a variety of matchers to make assertions more expressive. Common matchers include EC, which checks for equality, and B, which tests for identity. Include verifies if a collection contains a specific element, while have checks for the presence of attributes or methods. Match is used for regular expression comparisons. For Boolean checks, by truthy and befalsy are useful. Additionally, RayZeroer ensures that specific exceptions are triggered when expected. These matchers simplify test writing and make the intent of each test clear. Custom matchers can also be created to encapsulate complex logic, promoting reusability and reducing duplication across tests. Adhering to best practices in RSpec testing ensures tests are effective and maintainable. A test-first approach, where tests are written before code, encourages better design and clearer requirements. Keeping tests isolated and focused on a single behavior prevents interference between tests and makes failures easier to diagnose. Using before and after hooks allows for efficient setup and cleanup, such as initializing test data or resetting the environment. Clear and descriptive test names, like adds two numbers, make it easy to understand the purpose of each test without reading the implementation. These practices contribute to a robust and scalable testing suite. Common issues in RSpec testing include test failures due to incorrect expectations, which can stem from typos or misunderstandings of the code. Slow tests often result from inefficient setup, such as heavy database interactions, which can be mitigated by mocking dependencies. Overlapping test data can cause conflicts, especially when tests modify shared resources. To address this, use tools like let and subject to create reusable test data and avoid redundant setup. Mocking external services or databases ensures tests run quickly and independently, leading to a more reliable and efficient testing process. RSpec simplifies testing by providing a structured and expressive way to write tests, ultimately improving code reliability. Practicing thorough testing for all critical code paths ensures that changes do not introduce regressions. Leveraging RSpec's features, such as matchers and hooks, makes tests more readable and maintainable. Regular testing is essential for ensuring that code evolves without breaking existing functionality, fostering confidence in the application's stability. By integrating RSpec into your workflow, you create a culture of quality and continuous improvement in your Ruby projects. Debugging is the process of identifying and fixing errors in code. When you're writing Ruby programs, it's inevitable that some issues will arise. These errors can range from simple typos to complex logic problems. The key goals of debugging are to locate these bugs, understand why they occur, and take steps to prevent them from happening again. This skill is essential for Ruby developers because even the most well-written code can have unexpected behavior. By mastering debugging, you ensure that your applications run reliably and efficiently. Think of debugging as a detective work where you follow clues in your code to uncover the root cause of a problem. There are several tools available to help with debugging in Ruby. One of the simplest is the puts method, which outputs text to the console. The p method is similar, but provides more readable output, especially for complex objects like arrays or hashes. For more advanced debugging, Bybug allows you to pause execution and inspect variables step by step. Pry offers a REPL-style environment where you can explore your code interactively. RBtrace is useful for profiling and tracing method calls in running processes, which helps identify performance issues. Finally, the logger class enables structured logging, making it easier to track events and errors in production environments. Each tool serves a specific purpose, and knowing when to use them can save you a lot of time. Using puts and p is a straightforward way to debug your code. Insert put statements to print variable values or to track the flow of execution. For example, you might write puts value variable to see what a particular variable contains at a certain point in your program. The p method is especially helpful for debugging complex objects because it displays their structure in a more readable format. However, these tools have limitations. They can become overwhelming when dealing with nested data structures or large volumes of output. In such cases, more advanced tools like Bug or Pry might be more effective. Still, Puts and P remain invaluable for quick checks and simple debugging tasks. Interactive debugging with Bug is a powerful technique. By inserting the Bug keyword in your code, you can pause execution and inspect variables, step through code line by line, and evaluate expressions in real time. Commands like step allow you to move through your code one line at a time, while continue resumes execution until the next breakpoint. The break command sets new breakpoints, and list shows the surrounding code. Backtrace displays the call stack, helping you understand how the current code was reached. This tool works seamlessly with IRB, letting you interact with your program as it runs. It's particularly useful for understanding how your code behaves under different conditions and for isolating specific issues. The Pry gem offers a more flexible approach to interactive debugging. To start a Pry session, you simply add binding.pry in your code. Once the session begins, you can use tab completion to explore methods and variables, inspect object states, and even execute code on the fly. This makes Pry ideal for complex debugging scenarios where you need to experiment with different parts of your program. Unlike Bug, which focuses on stepping through code, Pry allows you to dive deeper into objects and evaluate expressions at any point. This flexibility can be a game changer when dealing with tricky bugs or when you need to test hypotheses about your code's behavior. RBTrace is a tool designed for profiling and tracing method calls in Ruby applications. It allows you to monitor running processes and analyze their execution. For example, you can use RBTrace PPID to trace the activities of a specific process, which is useful for diagnosing performance issues. The output from RBTrace shows call stacks and execution times, helping you identify bottlenecks or unexpected behavior. This is particularly useful for optimizing slow or unresponsive code, as it provides insights into how methods are called and how long they take to execute. By understanding the flow of your program at a deeper level, you can make informed decisions to improve its efficiency. Logging in Ruby is an essential practice for tracking events and debugging issues. The logger class provides a structured way to record information with different levels such as debug, info, warn, error, and fatal. For instance, logger new std out. Info event occurred outputs a message to the console, which can be useful during development. In production environments, you can configure log files to store these messages, making it easier to review past events. Logging helps you understand what your application is doing without relying on print statements, which can clutter your output. By using appropriate log levels, you can filter out irrelevant information and focus on the details that matter most. Error handling with begin rescue blocks is a fundamental part of writing robust Ruby code. The begin keyword marks the start of a block of code that might raise an exception. If an error occurs, the rescue clause catches it and allows you to handle the situation gracefully. For example, begin rescue equals E. End lets you capture the exception and respond accordingly. The ensure keyword ensures that certain code runs regardless of whether an exception was raised. This is useful for cleaning up resources like file handles or database connections. By using begin rescue, you can prevent your programs from crashing unexpectedly and provide more informative feedback to users or developers. Common Ruby errors include syntax errors, runtime errors, and logical errors. Syntax errors occur when your code violates Ruby's rules, such as missing an end keyword or incorrect brackets. These are usually easy to spot because Ruby will highlight them when you run your code. Runtime errors happen during execution, such as trying to call a method on a nil object or accessing an undefined variable. Logical errors are trickier because the code runs without crashing, but the results are incorrect due to flawed logic or business rules. Stack traces are invaluable for pinpointing where these errors occur, as they show the sequence of method calls leading up to the problem. Understanding these error types helps you diagnose and fix issues more efficiently. Adopting best practices can significantly reduce the time spent debugging and improve code quality. Writing unit tests using frameworks like Minitest or RSpec helps catch bugs early in the development cycle. Version control systems like Git allow you to track changes and revert to previous states if issues arise. Collaborating with peers through code reviews ensures that multiple people examine the code, increasing the chances of catching errors before they become problems. Documenting your debugging steps is also crucial, as it provides a reference for future troubleshooting and helps others understand the process. By combining these practices, you create a more reliable and maintainable code base. Debugging is a critical skill for building robust Ruby applications. By leveraging tools like Bybug, Pry, and logging, you can efficiently identify and resolve issues. Systematic error analysis, such as examining stack traces or using breakpoints, helps you understand the root causes of problems. Proactive testing, including writing unit tests and using version control, reduces the likelihood of bugs appearing in the first place. Applying these best practices not only saves time, but also enhances the overall quality of your code. Remember, debugging isn't just about fixing errors. It's about learning how your code behaves and improving it over time. Procs and lambdas are first-class objects in Ruby, meaning they can be treated like any other value in the language. This allows you to store blocks of code in variables, pass them around as arguments, and even return them from methods. These constructs are essential for functional programming patterns, enabling you to write more modular and reusable code. By using procs and lambdas, you can create flexible method calls where behavior is defined dynamically, making your code more adaptable to different scenarios. This flexibility is particularly useful when working with iterators, callbacks, or any situation where you need to pass custom logic to a method. A proc is a block of code that can be stored in a variable, allowing you to reuse it later. You can create a proc using the procnew method or the lambda keyword. For example, miproc equals procnew xx multiplied by 2 stores a block that multiplies a number by 2. Procs are often used to encapsulate reusable logic that can be passed to methods or executed at a later time. Because they are objects, you can assign them to variables, pass them as arguments, or even modify them dynamically. This makes procs a powerful tool for writing concise and expressive Ruby code. A lambda is a specialized type of proc that enforces strict argument checking. It is created using the lambda keyword or the arrow syntax. For instance, my lambda equals x multiplied by 2 defines a lambda that expects exactly one argument. Unlike procs, lambdas validate the number of arguments passed to them, ensuring that the code behaves predictably. This strictness makes lambdas ideal for scenarios where you need precise control over method parameters. Additionally, the arrow syntax provides a more concise and readable way to define lambdas, especially for simple operations. There are several key differences between procs and lambdas. First, argument handling. Procs are more lenient and accept any number of arguments, while lambdas require the exact number of arguments specified. Second, return behavior. When a proc returns, it exits the enclosing method, whereas a lambda returns only from itself. This distinction is critical for avoiding unexpected behavior in your code. Finally, syntax. Lambdas can be defined using the arrow syntax, which is more concise than the proc-new method. Understanding these differences helps you choose the right tool for the task at hand. Let me demonstrate how procs and lambdas work in practice. A proc example is proc equals proc-new, a, b plus b, which adds two numbers. A lambda example is lambda equals a, b plus b, which also adds two numbers. Both can be called using the call method or the square bracket syntax, like proc call 3, 4, or lambda 5, 6. While their syntax and behavior differ slightly, they are both powerful ways to encapsulate and reuse code. By mastering these constructs, you can write more efficient and maintainable Ruby programs. Choosing between procs and lambdas depends on your specific needs. Use procs when you need flexibility, such as in iterators or callbacks, where the number of arguments might vary. For example, a proc is perfect for a custom loop that processes elements in different ways. On the other hand, use lambdas when you require strictness, such as in method arguments or functional programming patterns, where precise parameter handling is essential. Lambdas ensure that your code behaves as expected, reducing the risk of runtime errors. Procs and lambdas are commonly used in various scenarios. One of the most frequent applications is passing blocks to methods, like the each or map methods in Ruby. They allow you to define custom behavior for each element in a collection. Additionally, they are great for creating reusable code snippets, such as validation logic or data transformation functions. Another powerful use case is implementing closures for delayed execution, where a block of code is stored and executed later, such as in event handlers or background tasks. These patterns make your code more modular and easier to manage. In conclusion, procs and lambdas are essential tools for code reusability and flexibility in Ruby. Understanding their differences ensures that you avoid runtime errors and write more predictable code. By mastering these constructs, you can enhance your ability to implement functional programming patterns, leading to cleaner and more efficient Ruby programs. Whether you're working on iterators, callbacks, or complex data transformations, procs and lambdas provide the building blocks to create dynamic and maintainable solutions. The enumerable module is a powerful tool in Ruby that provides a collection of methods for iterating over data structures. These methods allow developers to perform operations like transforming, filtering, and searching through elements in a concise and readable way. Classes such as array, hash, and string automatically include the enumerable module, which means they inherit all these iteration capabilities. Key methods like each, map, select, reject, find, and inject are widely used in Ruby programs to manipulate and process data efficiently. Understanding how these methods work is essential for writing clean and effective Ruby code. The enumerable module functions as a blueprint for adding iteration functionality to classes. To use the methods provided by enumerable, a class must implement an each method, which defines how the elements of the class are iterated over. Once the each method is defined, the class gains access to all the methods in enumerable, such as map, reduce, and sort. This design allows for a consistent and flexible approach to handling collections. For example, if a custom class has an each method, it can use map to transform its elements or sort to arrange them in a specific order. This modularity makes the enumerable module a cornerstone of Ruby's object-oriented design. Several methods are commonly used with the enumerable module to perform specific operations on collections. The each method is the most fundamental, as it allows you to loop through each element in a collection and execute a block of code. The map method transforms each element into a new value, creating a new array with the results. Select filters elements based on a condition, returning only those that meet the criteria. Reject does the opposite, removing elements that match a condition. Finally, find retrieves the first element that satisfies a given condition. These methods are designed to work seamlessly with arrays, hashes, and other enumerable objects, making data manipulation straightforward and expressive. Iterators in Ruby are methods that loop through elements of a collection, applying a block of code to each item. Common iterators include each, times, upto, and loop. Each of these methods provides a way to repeat actions for every element in a collection. For example, the times method can be used to execute a block a specific number of times, while upto iterates from a starting number to an ending number. Blocks, which are defined using the do keyword or curly braces, allow you to pass a piece of code to an iterator, making it possible to perform custom operations on each element. This block-based approach is a core feature of Ruby, enabling flexible and dynamic programming. Let's look at some practical examples of how enumerable methods can be applied in real-world scenarios. For instance, the map method can be used to double each element in an array. If you have an array like 1, 2, 3, using map with a block that multiplies each element by 2 would produce 2, 4, 6. The select method is useful for filtering data, such as extracting key-value pairs from a hash where the value exceeds a certain threshold. For example, a hash with values like A, 5, B, 15, C, 10 could be filtered to return B, 15, if the condition is that the value is greater than 10. Additionally, the eachchar method can iterate over each character in a string, allowing you to print or process individual characters one at a time. These examples demonstrate the versatility of enumerable methods in handling different data types. When working with enumerable methods, following best practices can significantly improve the quality of your code. For transformations, always use map to generate a new array of values based on existing elements. For filtering, rely on select to return elements that meet a specific condition, and use reject to remove unwanted elements. It's important to avoid modifying a collection while iterating over it, as this can lead to unexpected behavior or errors. Instead, create a new collection if changes are needed. Lastly, inject is a powerful tool for accumulating results, such as summing all elements in an array or concatenating strings. By adhering to these practices, you can write more efficient and maintainable Ruby programs. In summary, the enumerable module is a foundational part of Ruby that simplifies iteration and data manipulation. By providing a set of standardized methods, it allows developers to work with collections in a consistent and intuitive way. Understanding iterators and their applications enhances code efficiency and readability, making it easier to process and transform data. Whether you're working with arrays, hashes, or custom classes, the enumerable module offers a flexible and powerful toolkit. Applying these methods in your Ruby programs will help you write cleaner, more expressive, and more effective code. Metaprogramming in Ruby is a powerful concept that allows developers to write code that can create or modify other code at runtime. This capability is one of the key reasons Ruby is so flexible and expressive. Ruby's dynamic nature means that the language doesn't enforce strict rules about how code is structured or how objects behave. Instead, it provides tools like define method, eval, and method missing to manipulate code dynamically. For example, define method lets you add methods to a class or module after it has been defined, while eval allows you to execute strings as Ruby code. Method missing is another tool that enables you to handle calls to methods that don't exist, which is particularly useful for creating domain-specific languages or handling unpredictable inputs. The benefits of metaprogramming include reducing code duplication, enabling more dynamic behavior, and allowing for highly flexible applications. Common use cases include building domain-specific languages, such as rake tasks or active record queries, and generating code at runtime to adapt to changing requirements. Understanding Ruby's object model is essential for mastering metaprogramming. In Ruby, everything is an object, including classes and modules, which are themselves instances of the class and module classes. This means that classes and modules can be modified, extended, or even created dynamically. For instance, a class defines the behavior of its instances, but you can also add methods to individual objects without modifying the class itself. These are called singleton methods, and they are defined using techniques like class self or singleton method. The class self syntax opens the singleton class of an object, allowing you to add methods that only apply to that specific instance. Singleton methods are useful for creating unique behaviors for individual objects, such as customizing a single instance of a class without affecting others. This flexibility is a core part of Ruby's design and enables powerful metaprogramming patterns. Dynamic method creation is a core aspect of Ruby's metaprogramming capabilities. The define method method allows you to add methods to a class or module at runtime, which can be especially useful for generating code based on user input or configuration. For example, you could define a method called hello that prints high by using class my class. Define method hello. Puts high end. This approach can reduce boilerplate code and make your programs more adaptable. Another key tool is method missing, which allows you to handle calls to methods that don't exist. When a method is called that isn't defined, Ruby invokes method missing, giving you the opportunity to respond dynamically. You can also use respond to missing to control whether method missing should be triggered, which helps prevent unintended behavior. Together, these tools enable you to create highly dynamic applications where behavior can be adjusted on the fly. The eval and instance eval methods are powerful tools for executing Ruby code dynamically. Eval takes a string and evaluates it as Ruby code, which can be useful for generating code at runtime or executing user-defined scripts. However, this flexibility comes with risks, as eval can introduce security vulnerabilities if used with untrusted input. Instance eval, on the other hand, runs code in the context of a specific object, allowing you to modify its instance variables or call its methods directly. For example, obj_instance eval at var equals 10 would set the instance variable at var on the object. While these methods are incredibly useful, they should be used with caution. The dynamic nature of eval can make code harder to read and debug, and it can lead to unexpected side effects if not handled carefully. Always prioritize clarity and security when deciding whether to use eval in your programs. Singleton methods and classes allow you to add unique behaviors to individual objects without affecting their class or other instances. For example, you can define a method called hello directly on an object using def obj_hello high end. This method will only be available on that specific object, not on other instances of the same class. Ruby also provides tools like singleton method to manipulate these methods programmatically. Additionally, modules can be used to dynamically compose classes and objects. The prepend method allows you to insert a module before another in the method lookup chain, while include adds the module's methods to a class. Extend, on the other hand, adds module methods to a specific object, making them available as instance methods. These techniques are essential for creating flexible and reusable code, especially in scenarios where you need to customize behavior at runtime. Metaprogramming in Ruby relies on a set of techniques that allow you to manipulate code dynamically. One of the most common is method missing, which lets you handle undefined method calls by defining a custom response. Another technique is define singleton method, which adds methods to specific objects. Class eval and module eval are used to define code within the context of a class or module, allowing you to dynamically modify their structure. For example, you can use class eval to add methods to a class after it has been defined. The adder accessor and adder reader methods are also examples of metaprogramming, as they generate getter and setter methods at runtime. These tools are not just theoretical. They are widely used in Ruby libraries and frameworks to create flexible and expressive APIs. Understanding and mastering these techniques can significantly enhance your ability to write dynamic and maintainable Ruby code. Metaprogramming is widely used in real-world applications to create flexible and powerful systems. One of the most common use cases is building domain-specific languages, or DSLs. For example, Rake uses a DSL to define tasks, while Active Record uses a DSL to map database tables to Ruby classes. Another use case is implementing dynamic attributes or behaviors, where an object's methods or properties can change based on runtime conditions. This is particularly useful in scenarios where you need to adapt to varying input or configuration. Metaprogramming can also be used to create custom inheritance or proxy patterns, allowing you to control how objects interact with each other. For instance, the class self syntax is often used to define class methods, which can be useful for creating utility functions that are specific to a class. These examples demonstrate how metaprogramming can make Ruby code more expressive and adaptable. While metaprogramming offers many benefits, it also comes with challenges. One of the main pitfalls is overuse, which can lead to code that is difficult to read, understand, or maintain. When methods are created dynamically, it can be hard to trace their origin or predict their behavior. Debugging metaprogrammed code can also be challenging, as the actual method definitions may not be visible in the source code. Additionally, using eval in unsafe contexts, such as with user input, can introduce security vulnerabilities, as it allows arbitrary code execution. To mitigate these risks, it's important to document metaprogramming logic clearly and use it sparingly. Whenever possible, prefer simpler alternatives to dynamic code generation. By following best practices and being mindful of the trade-offs, you can harness the power of metaprogramming while keeping your code base clean and secure. Metaprogramming is one of the most powerful features of Ruby, enabling developers to create flexible and expressive code. However, mastering it requires a deep understanding of Ruby's object model and dynamic capabilities. By practicing with real-world examples, such as building DSLs or working with ORMs, you can gain hands-on experience with these techniques. In the next session, we will explore advanced Ruby patterns and idioms, building on the foundation of metaprogramming. These topics will further expand your ability to write efficient, maintainable, and elegant Ruby code. As you continue your journey, remember that the key to effective metaprogramming lies in balancing power with clarity, ensuring that your code remains both dynamic and understandable. Ruby gems are packages of code that extend Ruby's functionality. Think of them as pre-built tools that add new features or capabilities to your Ruby projects. They simplify sharing and reusing code across projects by allowing developers to distribute their code in a standardized way. For example, instead of writing code from scratch for common tasks, you can use a gem that already handles those functions. Gems are hosted on RubyGems.org, which is the default source for Ruby packages. This central repository makes it easy for developers to find and install gems. Each gem includes a gem spec file, which acts like a blueprint. This file defines the gem's metadata, such as its name, version, and authors, as well as its dependencies, which are other gems or libraries that it requires to work properly. To install gems, you use the gem command, which is a built-in tool in Ruby. The basic syntax is gem install followed by the name of the gem you want to install. For example, running gem install Rails will download and install the Rails framework, which is a popular web development toolkit. Gems can be installed globally, meaning they are available system-wide, or locally, which is typically managed through Bundler. Installing globally is useful for tools that you want to access from anywhere, but for project-specific dependencies, it's better to use Bundler. This tool allows you to specify dependencies in a gem file, which is a file in your project directory. The gem file acts as a list of all the gems your project needs, along with their versions. This ensures that everyone working on the project uses the same set of gems, reducing conflicts and making collaboration smoother. Bundler is the standard tool for managing gem dependencies in Ruby projects. When you start a new project, you create a gem file to list all the required gems and their versions. This file is crucial because it tells Bundler exactly what to install. Once the gem file is ready, you run bundle install, which downloads and installs all the gems specified in the file. This process ensures that your project has all the necessary dependencies in one go. Another key feature of Bundler is the gemfile lock, which records the exact versions of all installed gems. This lock file is essential because it ensures consistency across different environments, such as your local machine, a staging server, and a production server. Without the gemfile lock, different versions of the same gem might be installed in different environments, leading to unexpected behavior or errors. By default, Ruby Gems.org is the source where gems are fetched from. However, there are scenarios where you might need to use a different source. For instance, if you're working with a private gem server or a custom repository, you can add it using the gem sources command. The command gem sources https://rubigems.org/ adds a source to your list, allowing you to install gems from that location. You can also remove sources using gem sources R followed by the source URL. Configuration files like gemrc can further customize how Ruby Gems behaves. For example, gemrc might set default options for gem installation, such as the source or proxy settings. These configurations are especially useful for developers who work in environments with specific requirements or restrictions. Understanding how to manage sources and configurations gives you more control over where and how gems are installed. Updating and removing gems is an important part of maintaining a healthy Ruby project. To update a specific gem, you can use the gem update command followed by the gem name. For example, gem update Rails will check for the latest version of Rails and install it if available. Alternatively, you can run bundle update, which updates all gems specified in the gem file to their latest versions. However, it's crucial to test updates in a staging environment before deploying them to production. This helps catch any potential issues caused by changes in the updated gems. Removing unused gems is equally important. You can uninstall a gem using gem uninstall followed by the gem name. Regularly reviewing and updating gems helps prevent security vulnerabilities and ensures your project stays compatible with the latest Ruby versions and best practices. Following best practices for gem management is essential for for building reliable Ruby applications. First, always use Bundler to isolate project dependencies. This prevents conflicts between different projects that might require different versions of the same gem. Second, specify exact gem versions in your gem file. This ensures that your project uses the same versions of gems across all environments, avoiding unexpected behavior caused by version mismatches. Third, avoid installing gems globally for production projects. Global installations can lead to version conflicts and make it harder to manage dependencies for multiple projects. Finally, regularly review and update your gems. This includes checking for security patches, performance improvements, and compatibility with new Ruby versions. By adhering to these practices, you can maintain a secure, stable, and scalable Ruby application. Ruby gems streamline code sharing and dependency management by providing a standardized way to distribute and use code. This not only saves time, but also reduces errors that can occur when writing code from scratch. Bundler ensures consistent gem versions across environments, which is critical for maintaining predictable behavior in development, testing, and production. Proper gem management improves project reliability and security by keeping dependencies up to date and avoiding conflicts. As you continue learning Ruby, practice using gems and Bundler to build scalable applications. The more you work with these tools, the more comfortable you'll become with managing dependencies and leveraging the vast ecosystem of Ruby libraries to solve real-world problems. Ruby on Rails is a web application framework built using the Ruby programming language. It follows a specific architectural pattern known as Model View Controller, which helps organize code in a structured way. This framework is designed to make web development faster and more efficient by providing tools and conventions that reduce the need for repetitive code. One of the core principles of Ruby on Rails is convention over configuration, which means it makes assumptions about how things should be done, so you can focus on the unique aspects of your application. Another key idea is dry, or don't repeat yourself, which encourages writing code once and reusing it throughout the application to maintain clarity and reduce errors. Ruby on Rails offers several features that make it a powerful choice for web development. One of these is Active Record, which is a built-in tool for interacting with databases. It allows developers to work with database tables as if they were Ruby objects, making it easier to manage data. The framework also uses res-tful routing, which creates clean and readable URLs by following standard web conventions. Scaffolding is another feature that enables rapid prototyping by generating code for models, views, and controllers based on simple commands. The Ruby community is very active and provides a vast collection of libraries known as gems, which extend the functionality of Rails applications. Additionally, Ruby on Rails includes security measures to protect against common vulnerabilities, such as cross-site scripting and SQL injection. There are many reasons to choose Ruby on Rails for building web applications. One of the main advantages is its ability to speed up the development process. By following established conventions and providing pre-built tools, developers can create applications more quickly than with some other frameworks. Ruby on Rails is also scalable, which means it can handle projects of varying sizes, from small websites to large enterprise applications. The ecosystem of plugins and tools available through gems makes it easy to add features without starting from scratch. This framework is particularly well suited for startups and minimum viable products because it allows for rapid iteration and flexibility. Finally, Ruby on Rails prioritizes developer happiness by focusing on productivity and writing clean, maintainable code. Setting up Ruby on Rails requires a few steps to ensure the environment is properly configured. First, you need to install Ruby, which is the programming language that Rails is built on. Tools like RVM or RBenv can help manage different versions of Ruby on your system. Once Ruby is installed, you should install Ruby Gems, which is the package manager for Ruby. With Ruby Gems, you can easily install Rails by running a simple command. After installation, it's important to verify that everything is working correctly by checking the versions of Ruby and Rails using specific commands. Finally, choose a code editor like Visual Studio Code or Sublime Text to write and manage your Rails code efficiently. The model view controller architecture is a fundamental concept in Ruby on Rails. The model component is responsible for managing the data and business logic of the application. It interacts with the database and ensures data integrity. The view handles the user interface and determines how data is presented to the user. This separation of concerns makes the code easier to maintain and update. controller acts as the middleman between the model and the view. It receives user input, processes it using the model, and then selects the appropriate view to display the results. This structure helps keep the application organized and scalable. In Ruby on Rails, several components work together to create a functional web application. Roots define how URLs map to specific actions in controllers, making it easy to navigate the application. Controllers handle incoming requests from users and determine how to respond by interacting with models and views. Models manage the data and logic for the application, often using Active Record to communicate with the database. Views are responsible for generating the HTML that users see in their browsers. The database itself is managed through migrations, which allow developers to modify the database structure over time while keeping it consistent across different environments. Creating a simple Rails application involves a few straightforward steps. To begin, use the command Rails new followed by the name of your project to generate the basic structure. Navigate into the project directory using the cd command. Next, create a scaffold which automatically generates a model, controller, views, and database migration. For example, Rails generates scaffold post title, string body text will create a post model with title and body fields. Run the migration to set up the database by executing Rails db migrate. Finally, start the Rails server with Rails server and open a web browser to view the application at localhost 3000. This process demonstrates how Rails streamlines the development of web applications. Ruby on Rails is a powerful tool for building web applications with a focus on efficiency and maintainability. Understanding the model view controller pattern and the conventions of Rails is essential for creating well-structured code. Practicing by building small projects helps reinforce these concepts and build confidence. As you become more familiar with the framework, you can explore advanced topics, such as using gems to add functionality, implementing authentication systems, and deploying applications to production environments. Continued learning through official documentation and community resources ensures that you stay up to date with the latest best practices and techniques in Ruby on Rails development. Welcome to this session on Rails models, migrations, and databases. Rails provides a powerful way to interact with of databases through its built-in tools. Models are central to this process as they represent the data and business logic of your application. Migrations allow you to manage changes to the database schema over time, ensuring consistency across different environments. Databases themselves are the storage layer that holds all the data your application needs. By the end of this presentation, you will understand how these components work together to build robust web applications. Models in Rails are part of the Model View Controller architecture. They act as the middle layer between the database and the user interface, handling data validation, business rules, and interactions. For example, a user model might manage login functionality, while a product model could handle inventory tracking. Rails uses Active Record, a framework that simplifies database operations by mapping database tables to Ruby classes. Models also define relationships between data, such as a user having many orders or an order belonging to a single user. These associations make it easier to retrieve and manipulate related data. Creating a model in Rails is straightforward. You can use the generate command followed by the model name and any attributes. For instance, running Rails generate model username string email string will create a user model with name and email fields. This command automatically generates two files, one in the models directory and another migration file in the migrations folder. The migration file contains instructions for creating the corresponding database table. This process ensures that your database structure is always aligned with your application's needs. Migrations are essential for tracking changes to your database schema. Instead of manually altering the database, Rails stores these changes in Ruby files. This approach allows you to version control your database structure, making it easier to collaborate with others or roll back changes if needed. For example, if you add a new column to a table, the migration file records this change. When you run Rails DB migrate, Rails applies all pending migrations, updating the database. If something goes wrong, Rails DB rollback undoes the last migration, restoring the previous state. A migration file typically includes a change method that defines the database changes. For example, the createUsers class might use createEditable to build a user's table with name and email fields. The tstring method specifies the data type for each column, while ttimestamps adds automatic time tracking for record creation and updates. You can also use other column types like t-integer or t-boolean, depending on your needs. Each migration file is time-stamped to ensure changes are applied in the correct order. Configuring your database is a critical step in setting up a Rails application. The config/database YAML file holds settings for different environments, such as development, test, and production. By default, Rails uses SQLite for development, which is lightweight and easy to set up. However, for production, you might switch to PostgreSQL or MySQL for better performance. The configuration includes details like the adapter type, database name, and connection parameters. Properly setting this up ensures your application can access the database reliably. Database relationships are defined in models using associations like has many and belongs to. For example, an order model might belong to a user, indicating that each order is linked to a specific user. To support this, the orders table would include a userid foreign key. These relationships allow you to query data efficiently, such as retrieving all orders for a given user. Understanding how to set up and use these associations is key to building complex applications with interconnected data. Once your migrations are ready, you can apply them using Rails DB migrate. This command updates the database to match the latest schema. To verify the changes, Rails DB schema load rebuilds the database from the current schema file, which is useful when setting up a new environment. For testing, Rails DB test prepare ensures the test database is in sync with the development database. These tools help maintain consistency across different stages of development and testing. Common migration tasks include adding, removing, or renaming columns. For instance, add column users age integer introduces a new age field to the users table. If a column is no longer needed, remove a column users old column deletes it. Renaming a column involves rename column users old name new name. These operations allow you to evolve your database structure as your application's requirements change, ensuring it remains up to date. To recap, models encapsulate data and business logic. Migrations manage database schema changes, and databases store application data. Each component plays a vital role in building scalable and maintainable applications. Practice creating models, writing migrations, and configuring databases to reinforce your understanding. By mastering these concepts, you'll be better equipped to develop robust web applications with Rails. As you continue learning, explore advanced migration techniques like adding indexes for faster queries or using constraints to enforce data integrity. Optimizing database performance is also crucial for large-scale applications. Refer to the Rails guides for comprehensive documentation on migrations and database management. Keep experimenting and applying these concepts to real-world scenarios to deepen your expertise. Controllers serve as the central hub for managing user interactions within a Rails application. When a user sends a request, such as clicking a link or submitting a form, the controller receives that request and determines how to respond. It acts as the intermediary between the user and the application's data, executing the necessary logic to generate the appropriate response. Routing, on the other hand, is the process of mapping incoming HTTP requests to specific controller actions. This ensures that each request is directed to the correct part of the application. Together, controllers and routing form the foundation of dynamic web applications, allowing developers to create responsive and interactive user experiences. In Rails, controllers are implemented as Ruby classes that inherit from the action controller base class. This inheritance provides access to a suite of methods and functionalities tailored for handling web requests. Common actions within a controller include index, which displays a list of resources, show, which retrieves a specific resource, new, which prepares a form for creating a new resource, create, which saves a new resource, edit, which prepares a form for updating an existing resource, update, which modifies an existing resource, and destroy, which removes a resource. These actions follow the conventions of the model view controller architecture, enabling developers to build consistent and predictable applications. To respond to requests, controllers use either the render method, which displays a view, or the redirecto method, which sends the user to a different URL. Routing in Rails is defined in the config/routes RB file, where developers specify how URLs map to controller actions. This file uses a domain-specific language to describe the application's URL structure. The resources method is commonly used to generate standard res TFL routes for a resource, such as posts, users, or products. For example, resources Posts create 7 routes that correspond to the index: new, create, show, edit, update, and destroy actions. Res TFL routing aligns with HTTP verbs like get, post, PUT, and delete, ensuring that the application's URLs are intuitive and follow standard web conventions. This approach not only simplifies the development process, but also enhances the clarity and maintainability of the application's URL structure. When a request is made to a Rails application, the parameters sent with the request are accessible through the params hash within the controller. This hash contains key value pairs that represent the data submitted by the user, such as form inputs or query strings. To ensure security, Rails introduces strong parameters, which require developers to explicitly permit the parameters that can be used for mass assignment. This prevents malicious users from injecting unintended data into the application. Controller actions are responsible for processing these parameters, interacting with models to retrieve or modify data, and then generating a response. By handling business logic within actions, developers can maintain a clear separation of concerns, making the application easier to manage and scale. To maintain clean and maintainable code, it is essential to keep controllers thin by avoiding complex logic directly within them. Instead, developers should move such logic to models or service objects, which handle data processing and business rules. This practice enhances readability and makes the code base more modular. Another best practice is to use beforeaction, a method that allows developers to execute code before specific controller actions. This is particularly useful for tasks like authentication or setting up variables that are needed across multiple actions. Finally, prioritizing res TFL design ensures that the application's URLs and actions follow a consistent pattern, making it easier for developers to understand and extend the application over time. Controllers and routing are fundamental to the functionality of Rails applications, acting as the bridge between user input and the underlying data. Effective routing ensures that URLs are clean, intuitive, and easy to navigate, while controllers manage the logic required to fulfill user requests. By mastering these concepts, developers can build applications that are not only robust and scalable, but also maintainable and efficient. The principles of res TFL design along with best practices for controller structure and parameter handling, empower developers to create web applications that meet modern standards and user expectations. This understanding is crucial for anyone looking to build dynamic, high-quality web solutions using Ruby on Rails. Views are the part of a Ruby on Rails application that generate the HTML output users see in their browsers. They play a crucial role in separating the presentation logic from the business logic, which is a core principle of the model view controller architecture. This separation allows developers to focus on the data and functionality in the model and controller layers, while keeping the view layer clean and focused on how the data is displayed. Views are typically rendered by controllers, which pass the necessary data to the views before sending the final HTML to the client's browser. This process ensures that the application remains organized and easier to maintain over time. Template engines are essential tools that process views to create dynamic HTML content. They allow developers to embed Ruby code directly within HTML files, enabling the generation of content that changes based on data or user interactions. For example, a template engine can insert a user's name into a greeting message or display a list of products from a database. The most common template engines in the Ruby ecosystem include ERB, which is the default in Rails, as well as Haml and Slim, which offer alternative syntax styles. Another tool called Tilt acts as a middleware that supports multiple template engines, making it easier for Rails applications to switch between them if needed. ERB, or Embedded Ruby, is the default template engine in Ruby on Rails and has been widely used for many years. It allows developers to write HTML with embedded Ruby code using specific tags. The %= tag is used to output the result of a Ruby expression directly into the HTML, such as displaying a user's name. The %% tag, on the other hand, executes Ruby code without outputting anything, which is useful for control structures like loops or conditionals. For instance, you might use % if at user admin, % to conditionally render a section of the page. ERB's simplicity and integration with Rails make it a popular choice for many developers. While ERB is the default, alternatives like Haml and Slim offer more concise and readable syntax for writing views. Hamel uses indentation to represent nested HTML elements, eliminating the need for closing tags and reducing the amount of boilerplate code. For example, a Hamel file might look like %h1 welcome instead of h1 welcome/h1. Slim takes a similar approach, but with a slightly different syntax, using symbols like equals and to denote content, classes, and IDs. Both Hamel and Slim can make views more compact and easier to read, especially for developers who prefer a more minimalistic style. However, they require learning new syntax compared to the more traditional ERB approach. In a Rails application, views are stored in the app views directory, which is organized by controller names. For example, a controller called users controller would have its views in app views users. Each view file is named to match the corresponding controller action, such as show, HTML, herb for the show action. This naming convention makes it easy to locate the right view when working on a specific feature. Controllers use the render method to display these views, which can either be explicit, like render show, or implicit, where Rails automatically finds the view based on the action name. This structure ensures a clear and predictable flow of data and presentation in the application. Partials are a powerful feature in Rails that allow developers to reuse common view snippets across multiple pages. These reusable components are stored in files that start with an underscore, such as form, HTML, herb. Partials are rendered using the render method with the partial option, like render partial, form. This approach helps reduce code duplication and keeps the views dry. Don't repeat yourself. For example, a form for creating a user might be a partial used in both the new and edit actions. Partials can also accept local variables, making them even more flexible for different use cases. By organizing code into partials, developers can maintain a cleaner and more efficient code base. Layouts provide a consistent structure for views by wrapping them with shared HTML elements like headers, footers, and navigation bars. The main layout file is typically located at app/views/layouts/application. HTML, herb, but other layouts can be created for specific sections of the application. The key element in a layout is the %=yield% method, which acts as a placeholder for the specific view content. When a view is rendered, its HTML is inserted into the layout at the yield position, ensuring a unified look across the app. Layouts also allow for the inclusion of common assets like stylus sheets and JavaScript files, making it easier to manage the overall design and functionality of the application. Helpers are methods defined in the App Helpers directory that encapsulate reusable view logic. These methods can be called directly in views to generate HTML or perform common tasks. For example, the built-in Linkto helper creates a hyperlink, while Formfor generates a form for a model. Developers can also create custom helpers to handle specific tasks, such as formatting dates or generating navigation menus. By moving complex logic into helpers, views remain simpler and more focused on presentation. This separation of concerns makes the code base easier to test, maintain, and scale, as the logic is not scattered across multiple view files. Following best practices for views is essential for maintaining a clean and scalable code base. One key principle is to avoid placing heavy business logic directly in views, as this can make them difficult to test and maintain. Instead, logic should be handled in models or controllers. Reusing code through partials is another best practice, as it reduces duplication and ensures consistency. Additionally, adhering to naming conventions, such as using underscores for partials and matching file names to controller actions, helps keep the project organized. By following these guidelines, developers can create views that are easier to read, update, and collaborate on, ultimately leading to more reliable and efficient applications. In summary, views and template engines are fundamental to building dynamic web applications in Ruby. They enable the creation of HTML content that responds to user input and data changes, making the application more interactive and engaging. While ERB is the default and widely used template engine, alternatives like Haml and Slim offer different styles and syntax options. By leveraging layouts, partials, and helpers, developers can structure their code in a way that is both maintainable and scalable. These tools and practices ensure that the views remain focused on presentation, while keeping the overall application architecture clean and efficient. Res-T-Fold design is an architectural approach for creating networked applications that prioritize simplicity, scalability, and flexibility. At its core, REST stands for representational state transfer, which is not a specific protocol, but rather a set of constraints and principles that guide the development of web services. This design emphasizes stateless communication, meaning each request from a client to a server must contain all the information needed to understand and process it. This allows for greater scalability and reliability because the server does not need to store any session data. Additionally, REST relies on uniform interfaces, ensuring that interactions between clients and servers follow standardized patterns, such as using HTTP methods like GET, POST, PUT, and DELETE to perform actions. These principles make REST-TFL APIs a popular choice for building web services that can interact seamlessly with a wide range of clients, from web browsers to mobile applications. The key principles of REST-TFL design include statelessness, client-server architecture, uniform interface, layered systems, and cacheable responses. Statelessness ensures that every request is independent, which simplifies server management and improves fault tolerance. The client-server architecture separates the user interface from the data storage, allowing each component to evolve independently. A uniform interface is achieved through standard HTTP methods and resource-based URLs, making the system more predictable and easier to use. A layered system allows for the addition of intermediaries, such as proxies or load balancers, without disrupting the client-server relationship. Finally, cacheable responses improve performance by reducing redundant data transfer, as clients and intermediaries can store and reuse previously retrieved information. Together, these principles create a robust framework for building scalable and maintainable web services. When designing a REST-TFL API, it is essential to focus on resources rather than actions. This means using nouns in URLs to represent entities, such as users or orders, rather than verbs like get users. This approach aligns with the HTTP protocol's emphasis on resources and their representations. For example, a GET request to users retrieves a list of users, while a POST request to the same endpoint creates a new user. HTTP methods define the actions performed on resources: GET for retrieving data, POST for creating, PUT for updating, and DELETE for removing. Versioning is also critical to ensure backward compatibility as APIs evolve. Including a version number in the URL, such as V1 users, allows developers to manage changes without breaking existing clients. By adhering to these conventions, REST-TFL APIs become more intuitive and easier to integrate with other systems. HTTP status codes are a vital part of REST-TFL communication, providing clear feedback about the outcome of a request. A 200 OK status indicates that the request was successful and the server is returning the expected data. A 201 created status is used when a resource is successfully created, often including a location header pointing to the new resource. A 400 bad request suggests that the client's input is invalid, such as missing parameters or incorrect data formats. A 404 not found means the requested resource does not exist, which could result from an incorrect URL or a deleted entity. Finally, a 500 server error signals an internal problem on the server side, such as a bug or configuration issue. Understanding these codes helps developers diagnose issues quickly and ensures that clients can respond appropriately to different scenarios. Ruby on Rails offers powerful tools to build REST-TFL APIs efficiently. One of the most important features is the resources method in the roots file, which automatically generates standard REST-TFL roots for a given resource. For example, resources users creates roots for index, show, create, update, and destroy actions, mapping them to corresponding controller methods. Controllers in Rails handle incoming HTTP requests and return responses, often in JSON format, to facilitate data exchange with clients. This convention over configuration approach reduces boilerplate code and ensures consistency across the application. By leveraging Rails' built-in support for REST-TFL design, developers can focus on implementing business logic rather than managing low-level details of the API. Building a REST-TFL API in Ruby involves several key steps. First, define roots in the config/routes RB file to map HTTP methods and URLs to controller actions. For instance, a GET request to users would trigger the index action in the user's controller. Next, create controllers with methods that handle each HTTP verb, such as show for retrieving a specific user or update for modifying their data. To format responses, Developers often use serializers like Active Model Serializer, which convert model objects into JSON structures. Authentication is another critical aspect, with options like JWT JSON Web Tokens allowing secure and stateless user verification. By following these practices, Ruby developers can create APIs that are both functional and secure. Adhering to best practices ensures that REST-TFL APIs are maintainable, efficient, and user-friendly. Consistent naming conventions for resources, such as plural nouns and hyphenated identifiers, make the API easier to navigate. Limiting data returned in responses, such as by implementing pagination, prevents performance issues with large data sets. Documenting the API using tools like Swagger or Postman helps developers understand its capabilities and usage. Validating input thoroughly guards against malformed requests and potential security vulnerabilities. Finally, testing the API with frameworks like RSpec or command line tools like curl ensures that it behaves as expected under various conditions. These practices collectively enhance the reliability and usability of the API. REST-TFL design provides a foundation for creating scalable, maintainable, and interoperable APIs. By focusing on resources, standard HTTP methods, and stateless communication, developers can build systems that are easy to understand and extend. Ruby on Rails further simplifies this process by offering built-in conventions and tools that align with REST-TFL principles. As with any technology, the key to mastering REST-TFL APIs lies in practice, experimenting with different scenarios, testing thoroughly, and refining designs based on feedback. Whether building a simple web service or a complex distributed system, the principles of REST and the capabilities of Ruby on Rails empower developers to create robust and efficient solutions. Today, we will explore the topic of working with JSON and XML in Ruby programming. These two formats are essential for data exchange in modern applications, especially when dealing with web services, APIs, and configuration files. We will cover key areas such as parsing JSON and XML data, generating these formats from Ruby objects, and understanding their practical applications in real-world scenarios. By the end of this session, you will have a clear understanding of how to handle these data formats effectively JSON, or JavaScript Object Notation, is a lightweight and text-based format that is widely used for data interchange. It is easy to read and write for both humans and machines, making it ideal for web APIs. XML, or Extensible Markup Language, is a more structured format that allows for complex data representation. It is often used in scenarios where data needs to be highly organized, such as in document storage or legacy systems. Both JSON and XML play critical roles in modern software development, particularly in scenarios where data needs to be transferred between different systems or stored in a structured manner. Parsing JSON in Ruby is straightforward thanks to the built-in JSON module. This module provides methods like JSON parse, which takes a JSON string and converts it into a Ruby object, such as a hash or array. For example, if you have a JSON string representing a user profile, parsing it will allow you to access the data using Ruby syntax. The JSON module also handles nested structures and arrays seamlessly, meaning you can work with complex data without additional overhead. This makes it a powerful tool for processing data from APIs or external sources. Generating JSON from Ruby objects is equally simple. The Hodgson method is available on many Ruby objects, including hashes and arrays. For instance, if you have a hash containing user data, calling Hodgson on, it will convert the hash into a JSON string. You can also customize the output using options like indent to add spaces for readability, or space to control the spacing between elements. This is particularly useful when you need to format the JSON for human readability, or when sending data to a client application. When working with XML in Ruby, the Nakajiri gem is the most popular tool. It allows you to parse XML strings into a document object, which you can then navigate and manipulate. For example, using Nakajiri, LXML string creates a document that you can query with methods like search, CSS, or XPath. These methods enable you to extract specific elements or attributes from the XML structure, making it easier to work with complex data. Nakajiri is especially powerful for tasks like web scraping or processing XML-based configuration files. Generating XML in Ruby can be done using the Nakajiri XML Builder class. This allows you to construct XML documents programmatically by defining elements and attributes. For instance, you can create a root element, add child elements, and set attributes dynamically. This approach is ideal for generating XML responses in web applications or exporting data in a structured format. After building the XML, it is important to validate it to ensure it follows the correct syntax and structure, which helps prevent errors in downstream processing. Comparing JSON and XML. JSON is known for its simplicity and ease of use, making it a preferred choice for modern APIs and data transfer. Its syntax is less verbose, which reduces the amount of code needed to represent data. On the other hand, XML is more structured and supports complex data hierarchies, making it suitable for document storage or systems requiring strict validation. The choice between the two depends on the specific requirements of your project. For example, JSON is often used in web services, while XML is more common in legacy systems or scenarios involving document-based data. JSON is commonly used in API responses, configuration files, and data transfer between clients and servers. Its lightweight nature makes it efficient for transmitting data over the network. XML, on the other hand, is frequently used in document storage, such as in RSS feeds or SOAP-based web services, and for data that requires a high level of structure. For instance, XML is well suited for representing hierarchical data, like a company's organizational chart, while JSON is better for sending data to a mobile application. Understanding these use cases helps you choose the right format for your needs. To work effectively with JSON and XML in Ruby, it is important to follow best practices. Always validate input data to avoid errors caused by malformed strings. Use libraries like the built-in JSON module or the Nakajiri gem for parsing and generating data, as they handle edge cases and provide reliable functionality. Additionally, keep your data structures simple and well documented to ensure clarity and maintainability. These practices help prevent common issues and make your code more robust and easier to understand. In conclusion, JSON and XML are fundamental tools for data exchange in Ruby applications. Mastering their parsing and generation is crucial for developing efficient and scalable solutions. By applying the concepts discussed today, you will be able to handle data in various formats with confidence. Remember to practice with real-world examples to reinforce your understanding, and continue exploring how these formats can be integrated into your future projects. Security is a critical aspect of building reliable and trustworthy web applications. As developers, we must prioritize protecting both our systems and the users who interact with them. Web applications are often targeted by malicious actors seeking to exploit vulnerabilities, which can lead to data breaches, financial loss, or reputational damage. Understanding common threats such as SQL injection, cross-site scripting, cross-site request forgery, and insecure dependencies is essential. These threats can compromise the integrity of your application, steal sensitive information, or even take control of user accounts. By adopting proactive measures, such as implementing secure coding practices and using the right tools, we can significantly reduce risks and create a safer digital environment for everyone. One of the most common vulnerabilities in web applications is SQL injection, which occurs when an attacker manipulates database queries to execute unauthorized commands. To prevent this, we should always use active records query methods, like where instead of concatenating strings to build SQL queries. This approach ensures that user inputs are treated as data rather than executable code. For example, using wherename. Params name is safer than constructing a query string manually. Additionally, avoid writing raw SQL statements whenever possible. Instead, rely on parameterized queries, which separate the data from the command logic. Regularly updating the Rails framework and database gems is also crucial, as these updates often include security patches that address known vulnerabilities. By following these practices, we can protect our applications from malicious database interactions. Cross-site scripting, or XSS, is another significant threat where attackers inject malicious scripts into web pages viewed by other users. These scripts can steal session cookies, redirect users to phishing sites, or perform actions on their behalf. To mitigate XSS, we must escape user input before rendering it in the browser. Rails provides helpers like H or HTMLescape for this purpose, which converts special characters into their HTML equivalents. For user-generated content that allows limited HTML, the sanitize method can restrict which tags and attributes are permitted. Additionally, implementing content security policy headers adds a layer of defense by specifying which sources of content are allowed to execute. Together, these techniques help prevent attackers from injecting harmful scripts into our applications. Cross-site request forgery, or CSRF, occurs when an attacker tricks a user into performing an action they did not intend, such as transferring funds or changing account settings. Rails includes built-in CSRF protection through the use of tokens, which are generated and embedded in forms and headers. These tokens ensure that requests originate from the intended application and not from a malicious site. To further strengthen this, we should validate HTTP methods for actions that modify data, such as using delete for destructive operations instead of get. This prevents unauthorized actions from being triggered through simple links or image tags. Finally, avoid exposing sensitive actions without proper authentication, such as requiring users to log in before accessing critical features. These steps help safeguard our applications against CSRF attacks. Secure authentication and password handling are foundational to protecting user accounts. Instead of using HasSecure Password, which is a Rails method, we should rely on bcrypt for password hashing. Bcrypt is designed to be slow and computationally intensive, making it resistant to brute force attacks. Storing passwords as plain text is a major security risk, so always use cryptographic hashing to store them securely. Additionally, implementing rate limiting for login attempts can prevent automated attacks that try to guess passwords. By combining strong hashing algorithms with proactive measures like rate limiting, we create a robust defense against unauthorized access to user accounts. Input validation and sanitization are essential for ensuring that user-provided data meets expected criteria. In Rails, strong parameters is a key tool for filtering and permitting only the necessary parameters, preventing unexpected or malicious input from being processed. Using regular expressions allows us to define strict patterns for input formats, such as email addresses or phone numbers. It is also important to avoid trusting external data sources, such as API responses or cookies, without proper validation. Even data from trusted sources can be compromised, so always assume that inputs may contain harmful content. By enforcing strict validation rules, we reduce the risk of injection attacks and other vulnerabilities. Managing dependencies and keeping them up to date is a critical part of maintaining a secure application. Third-party gems can introduce vulnerabilities if not monitored regularly. Using Bundle Update ensures that we are using the latest versions of our dependencies, which often include security fixes. Tools like Bundle Audit can scan our gemfile lock for known vulnerabilities in the gems we use. Additionally, minimizing the number of third-party libraries reduces the attack surface of our application. When we do use external libraries, it is important to review their security practices and ensure they are actively maintained. By staying vigilant about dependency management, we can prevent potential exploits from outdated or insecure code. Adopting secure coding practices is a proactive approach to minimizing vulnerabilities in our applications. One key principle is the principle of least privilege, which means granting users and processes only the permissions they need to perform their tasks. For example, database access should be restricted to specific tables or actions, reducing the impact of a potential breach. Logging errors securely is another important practice. Exposing stack traces to users can reveal sensitive information about the application structure. Instead, log errors in a controlled environment and display generic messages to users. Finally, using environment variables to store sensitive data, such as API keys or database credentials, prevents these values from being hard-coded into the application or exposed in version control systems. Several tools can enhance the security of Ruby applications. Brakeman is a static analysis tool specifically designed for Rails applications, identifying potential security issues in the codebase. It checks for common vulnerabilities like SQL injection, XSS, and insecure configurations. RuboCop is another tool that enforces both style and security guidelines, helping maintain consistent and secure code practices. For dynamic analysis, OWASP ZAP Z Attack Proxy allows us to scan web applications for vulnerabilities by simulating attacks and identifying weaknesses. By integrating these tools into our development workflow, we can detect and address security issues early, reducing the risk of exploits in production. Security is an ongoing process that requires continuous attention and adaptation. No single practice or tool can provide complete protection, but combining best practices with the right tools creates a robust defense. Staying informed about new vulnerabilities, updates, and emerging threats is crucial for maintaining a secure application. As developers, we must remain vigilant, regularly review our code, and keep our dependencies updated. By fostering a culture of security awareness, we can build applications that are not only functional, but also safe and reliable for users. Performance optimization in Ruby refers to the process of refining code to run faster, use fewer resources, and handle larger workloads efficiently. This is crucial because inefficient code can lead to slow response times, higher server costs, and a poor user experience. When applications scale, even small inefficiencies can become major issues. For example, a slow algorithm might work fine for a few users, but cause delays as traffic grows. Common bottlenecks include slow algorithms that perform unnecessary computations, memory leaks where unused objects are not properly released, and I/O operations such as reading from or writing to a database or file system, which are often much slower than in-memory processes. Addressing these issues ensures your application remains responsive and maintainable. To identify performance issues in Ruby, you can use tools like RubyProv, which measures the execution time of methods and helps pinpoint where your code spends the most time. By analyzing stack traces, you can see the sequence of method calls leading to a bottleneck, making it easier to trace the root cause. The benchmark module is another essential tool for comparing the performance of different code snippets. For instance, you might use it to test whether a loop or an enumerable method like map runs faster. These tools work together to give you a clear picture of where optimizations are needed. Improving code efficiency often starts with avoiding unnecessary loops. Ruby's enumerable methods such as map, select, and find are designed to handle common operations more concisely and efficiently than manual loops. For example, using find to search for an element in an array stops as soon as the first match is found, whereas each would iterate through all elements. This reduces both time and computational overhead. Additionally, minimizing object creation in loops is critical. For instance, using string sub in a loop can create new string objects repeatedly, which increases memory usage. Instead, consider reusing variables or using methods that avoid unnecessary allocations. These practices lead to cleaner, faster code. Memory management in Ruby requires careful attention to reduce allocation and garbage collection overhead. Methods like string freeze can prevent strings from being modified, which reduces memory usage and improves performance. The object tap method allows you to chain operations without creating intermediate variables, keeping memory usage lower. To monitor memory usage, you can use GCStat to check garbage collection statistics and object space to track objects in memory. For example, if you notice unexpected increases in object counts, it might indicate a memory leak. Always ensure that resources like file handles or database connections are properly closed to prevent leaks, which can degrade performance over time. Database optimization is vital for maintaining fast application performance. When fetching data, using includes or eager load in Active Record reduces the number of database queries by loading associated records in a single query, avoiding the n+1 problem. Adding indexes to columns that are frequently searched or filtered can significantly speed up query execution. For example, an index on a user's email column makes lookups much faster. When updating multiple records, batch updates with updateall are far more efficient than saving each record individually, as they minimize the number of database round trips. These strategies ensure your database interactions remain swift and scalable. Caching strategies help reduce the load on your application by storing results of expensive operations. In Rails, the Rails cache object provides a flexible way to cache data, whether it's the result of a complex computation or a database query. Fragment caching allows you to cache parts of a view, so repeated rendering of the same content is avoided. For example, a product listing page might cache the HTML for each product to speed up page generation. HTTP caching, such as using cache control headers, enables browsers and proxies to store responses, reducing the need to refetch data. Combining these approaches can drastically improve performance and reduce server load. In summary, performance optimization in Ruby requires a systematic approach. Start by profiling your code to identify bottlenecks, then focus on improving algorithms and reducing unnecessary operations. Tools like RubyProf and benchmark help you measure and compare performance, while techniques like caching and efficient database queries provide significant gains. By combining these methods, you can create applications that are not only fast, but also scalable and maintainable. Remember, even small optimizations can have a big impact when applied thoughtfully. Design patterns are like blueprints that provide proven solutions to common challenges in software development. They help us create code that is not only more structured, but also easier to maintain and scale over time. In Ruby, these patterns are especially valuable because they allow us to build applications that are both flexible and efficient. By leveraging design patterns, we can avoid reinventing the wheel and focus on solving unique problems with confidence. Using design patterns is like having a toolkit of tested strategies to address recurring issues in our code. This approach makes our code more readable, which is crucial when multiple developers work on the same project. It also makes our code more adaptable, so when requirements change, we can modify the system without rewriting large portions of it. This adaptability is key to creating software that evolves with the needs of users and businesses. In Ruby, several design patterns are frequently used to solve specific problems. The singleton pattern ensures that a class has only one instance, which is useful for managing shared resources. The factory pattern centralizes the creation of objects, reducing complexity in client code. The observer pattern enables objects to communicate in an event-driven way. The strategy pattern allows us to swap out algorithms dynamically, and the decorator pattern lets us add behaviors to objects without altering their structure. These patterns form the foundation of many Ruby applications. The singleton pattern in Ruby is implemented using the singleton module. By including this module in a class, we ensure that only one instance of that class exists throughout the application. For example, a logger class might use this pattern to maintain a single source of truth for log entries. This approach is ideal for scenarios where global access to a shared resource is necessary, such as configuration settings or connection pools. The factory pattern is a powerful way to create objects without exposing the instantiation logic directly. Instead of using the new keyword, we define a factory method that handles the creation process. This decouples the client code from the specific classes it uses, making the system more modular. For instance, A factory method might return different types of database connections based on the environment, allowing the rest of the application to remain unaware of the underlying implementation. The observer pattern establishes a one-to-many relationship between objects, where changes in one object trigger updates in others. In Ruby, this is often achieved using the observer and observable modules. For example, a notification system might use this pattern to inform multiple subscribers when a new message arrives. This approach promotes loose coupling, making it easier to add or remove observers without modifying the subject class. The strategy pattern allows us to encapsulate different algorithms within separate classes, making it easy to switch between them at runtime. For instance, a payment processing system might use this pattern to support multiple payment methods like credit cards, PayPal, or cryptocurrency. By isolating the algorithm logic, we can modify or extend the behavior of an object without changing its interface, leading to cleaner and more maintainable code. The decorator pattern is all about adding responsibilities to objects dynamically. Instead of using inheritance, which can lead to rigid hierarchies, we use composition to wrap objects with additional functionality. For example, a text editor might use decorators to add features like bold formatting or spell checking without subclassing the core editor class. This approach keeps the code base flexible and avoids the pitfalls of deep inheritance chains. The command pattern encapsulates requests as objects, enabling operations to be performed, queued, or undone. This is particularly useful for implementing features like undo-redo in applications. For example, a text editor might use the command pattern to represent actions such as typing, deleting, or formatting. By treating these actions as objects, we can store them, pass them around, and even execute them at a later time, which enhances the overall user experience. Design patterns bring numerous benefits to software development. They encourage code reuse by providing standardized solutions, which reduces redundancy and speeds up development. They also improve modularity, making it easier to test and maintain individual components. Additionally, design patterns create a common language among developers, which streamlines collaboration and ensures that everyone understands the structure and intent of the code base. In conclusion, design patterns are essential tools for writing structured and scalable Ruby applications. They help us create code that is easier to maintain, extend, and understand. By mastering these patterns, we can solve complex problems more efficiently and build systems that adapt to changing requirements. The key to success lies in practicing these patterns regularly and applying them to real-world scenarios to see their full potential. Good afternoon. Today, we will explore advanced object-oriented programming concepts in Ruby, focusing on two essential design patterns. Let us begin with a quick recap of fundamental OOP principles. Classes and objects form the backbone of object-oriented programming, allowing us to model real-world entities. Inheritance enables code reuse by creating hierarchies of classes, while encapsulation hides internal state and exposes controlled access through methods. These basics are crucial, but as applications grow in complexity, we need more sophisticated strategies. Advanced design patterns like singleton and factory help manage scalability, maintainability, and flexibility. By the end of this session, you will understand how these patterns solve common challenges in Ruby development. The singleton pattern is a design pattern that ensures a class has only one instance throughout the application lifecycle. This single instance acts as a global access point, making it ideal for resources that need to be shared across different parts of the system. For example, configuration settings, database connections, or logging systems often benefit from this approach. By limiting instantiation to a single object, the singleton pattern prevents inconsistencies that could arise from multiple independent instances. It also simplifies access to these shared resources, as any part of the code can retrieve the same instance without needing to pass it around explicitly. Implementing the singleton pattern in Ruby is straightforward. Ruby provides a built-in module called singleton, which we can include or extend in our class. When we include singleton, the class itself becomes a singleton, and we can access its instance via the class method instance. For example, consider a logger class. By including singleton, we ensure that only one logger instance exists. The log method can then be called on this single instance, guaranteeing consistent behavior. This approach is particularly useful for managing state that should remain uniform across the entire application. Singletons are particularly valuable in scenarios where a single point of control is necessary. For instance, a configuration manager might use a singleton to store and retrieve settings, ensuring all parts of the application use the same data. Similarly, a caching system could leverage a singleton to maintain a centralized cache, reducing redundant computations. Another common use case is for resources that are expensive to create, such as database connections. By reusing a single instance, we avoid the overhead of repeatedly initializing these resources. However, it is important to use singletons judiciously, as overuse can lead to tightly coupled code that is difficult to test and maintain. The factory pattern is another essential design pattern that focuses on object creation. Rather than directly instantiating objects, the factory pattern delegates this responsibility to a separate class or method. This approach encapsulates the logic for creating objects, making the code more modular and easier to manage. By abstracting the creation process, clients of the factory do not need to know the specific details of how objects are constructed. This separation of concerns enhances flexibility, allowing us to introduce new object types without modifying existing code. The factory pattern is particularly useful when dealing with complex object hierarchies, or when the creation process involves conditional logic. Let us look at an example of the factory pattern in Ruby. Suppose we have a vehicle factory class that creates different types of vehicles. The create a vehicle method uses a case statement to determine which class to instantiate based on the input type. For instance, if the type is car, the method returns a new car instance, and if it is bike, it returns a new bike instance. This approach centralizes the creation logic, making it easier to update or extend the system. For example, adding a new vehicle type would only require modifying the factory class, not every place where vehicles are created. This encapsulation of object creation reduces dependencies and improves code maintainability. The factory pattern is especially useful in scenarios where object creation logic is complex or subject to change. For example, in a system that supports multiple payment methods, a factory could handle the creation of different payment processors based on user input. This decouples the client code from the specific classes, allowing for greater flexibility. Factories also help manage dependencies, as they can inject necessary parameters or configurations during object creation. By hiding the complexity of object instantiation, the factory pattern simplifies the client code, making it more readable and easier to test. While both singleton and factory patterns serve distinct purposes. They share a common goal of improving code organization and maintainability. The singleton pattern focuses on controlling the number of instances, ensuring a single point of access for shared resources. In contrast, the factory pattern emphasizes encapsulating object creation logic, allowing for dynamic and flexible instantiation. Understanding when to use each pattern is crucial. For example, a singleton might be used to manage a shared configuration, while a factory could be employed to create different types of user interfaces based on user preferences. Both patterns contribute to separation of concerns, but their applications vary depending on the specific needs of the system. When implementing these patterns, it is important to follow best practices to avoid common pitfalls. For singletons, overuse can lead to tightly coupled code, making it difficult to test and modify. It is advisable to use singletons only when a single instance is truly necessary. For factories, overcomplicating the creation logic can introduce unnecessary complexity. Keeping the factory's responsibility focused on object creation ensures clarity and maintainability. Additionally, thorough testing is essential to verify that both patterns behave as expected. Unit tests can help catch issues such as incorrect object instantiation or unintended multiple instances. By adhering to these guidelines, developers can harness the benefits of these patterns without introducing new challenges. In summary, the singleton and factory patterns are powerful tools for advanced object-oriented programming in Ruby. The singleton pattern ensures that a class has a single instance, making it ideal for managing shared resources. The factory pattern, on the other hand, simplifies object creation by encapsulating the logic within a dedicated class. Both patterns contribute to cleaner, more maintainable code by promoting separation of concerns. However, their effective use requires careful consideration of the specific requirements of the application. By applying these patterns judiciously, developers can build scalable, flexible, and robust Ruby applications. Concurrency refers to the ability to execute multiple tasks in overlapping periods, allowing different parts of a program to progress simultaneously. This is distinct from parallelism, which involves true simultaneous execution. Multi-threading is a specific approach where multiple threads operate within a single process, sharing the same memory space and resources. Ruby's concurrency model relies heavily on threads to enable parallel execution, making it possible to handle multiple tasks at once. However, it's important to note that Ruby's threads are not true parallel threads due to the global interpreter lock, which we'll discuss in the next slide. The key benefits of concurrency include improved performance, especially for I/O-bound tasks, and enhanced responsiveness in applications that need to handle multiple user interactions or background processes. In Ruby, threads can be created using the thread.new method, which initiates a new thread of execution. For example, the code thread equals thread.new curly brace puts hello. Curly brace starts a thread that prints the word hello. Threads in Ruby share the same memory space, which means they can access and modify the same variables and objects. This shared memory is both a powerful feature and a potential source of issues, as we'll explore later. To ensure that the main program waits for all threads to complete before exiting, we use the join method. This is crucial for coordinating the completion of tasks and avoiding premature termination of the program. One of the most important aspects of Ruby's concurrency model is the Global Interpreter Lock, or GIL. The GIL is a mechanism that ensures only one thread executes Ruby code at a time, even on multi-core processors. This means that Ruby threads do not achieve true parallelism across multiple CPU cores. Instead, they run in a single process, which can lead to performance bottlenecks for CPU-bound tasks, such as heavy computations. However, the GIL is not a complete barrier to concurrency. For I/O-bound tasks, such as waiting for network responses or file operations, threads can still provide significant performance improvements. Understanding the GIL's limitations is essential for designing efficient Ruby applications. When working with threads, it's crucial to manage access to shared resources to avoid race conditions, which occur when multiple threads attempt to modify the same data simultaneously. To address this, Ruby provides the mutex class, which acts as a lock to ensure that only one thread can execute a block of code at a time. For example, by creating a mutex and using the synchronize method, we can protect critical sections of code. This approach ensures thread-safe access to shared resources, preventing data corruption. However, developers must be cautious about the order in which locks are acquired to avoid deadlocks, where two or more threads wait indefinitely for each other to release locks. Proper synchronization practices are vital for writing reliable concurrent code. While threads are a powerful tool for concurrency, Ruby also offers fibers, which are lightweight and based on cooperative multitasking. Unlike threads, which are preemptively scheduled by the operating system, fibers yield control explicitly, allowing developers to manage context switches manually. This makes fibers ideal for implementing coroutines, where tasks can pause and resume execution in a controlled manner. For example, a fiber might process a task, then pass control to another fiber before resuming itself. Threads, on the other hand, are better suited for true parallelism. Although Ruby's GIL limits their effectiveness for CPU-bound work. Understanding the differences between threads and fibers helps developers choose the right tool for their specific use cases. Concurrency patterns, such as producer-consumer, actor-model, and futures, are commonly used to structure complex applications. The producer-consumer pattern involves one thread generating data and another processing it, often using a queue to buffer the data. Ruby's queue class provides a thread-safe way to implement this pattern, ensuring that producers and consumers can communicate efficiently. The actor model, popularized by libraries like Celluloid, uses independent actors that communicate via message passing, reducing the need for shared state. Futures, on the other hand, allow asynchronous computation by returning a placeholder for a value that will be available later. These patterns help manage complexity and improve the scalability of concurrent applications. Multi-threading introduces several challenges that developers must carefully navigate. Shared state can lead to unpredictable behavior if not properly managed, requiring careful synchronization. Race conditions and deadlocks are common pitfalls that can be difficult to debug, especially in large applications. Debugging concurrent code is inherently more complex due to the non-deterministic nature of thread execution. Additionally, Ruby's GIL limits the ability to leverage multiple CPU cores for CPU-bound tasks, making it less effective for certain workloads. Despite these challenges, concurrency remains a valuable tool when applied correctly, and understanding its trade-offs is essential for building robust Ruby applications. In summary, concurrency is a powerful technique for improving application performance and responsiveness, particularly for I/O-bound tasks. Ruby's threads provide a flexible way to implement concurrency, but developers must be aware of the limitations imposed by the global interpreter lock. Synchronization mechanisms like mutexes are critical for ensuring thread safety and avoiding race conditions. When choosing between threads, fibers, and other concurrency models, it's important to consider the specific requirements of the task at hand. By understanding the strengths and weaknesses of each approach, developers can design efficient and reliable concurrent systems in Ruby. Ruby is a vibrant, open-source programming language with a strong global community that has grown significantly over the years. This community is not just a group of developers, but a collective of passionate individuals who collaborate to push the boundaries of what Ruby can achieve. The community-driven development model ensures that Ruby continues to evolve through the contributions of its members, fostering innovation and improvement in both the language itself and its ecosystem. Key platforms such as Ruby Gems, which serves as the primary package manager for Ruby, GitHub, where most Ruby projects are hosted and collaborated on, Stack Overflow, a go-to resource for troubleshooting and learning, and the Ruby forums, which provide a space for discussions and support, all play a crucial role in maintaining this active community. Additionally, events like RubyConf, an annual gathering of Ruby enthusiasts, and local meetups, which offer opportunities for face-to-face interactions, further strengthen the bonds within the community. These events are not just about sharing knowledge, but also about building relationships and fostering a sense of belonging among developers of all skill levels. The power of open source in Ruby lies in its ability to bring together developers from around the world to collaborate, share, and improve code. This collaborative spirit is the foundation of Ruby's success, as it allows for the continuous refinement of both the language and its associated tools. Projects like Ruby on Rails, a web application framework that has revolutionized web development, Sinatra, a lightweight framework for building web applications, and Hanami, a modern framework for creating scalable applications, are all built on the principles of open source. These projects benefit from the collective expertise of the community, leading to rapid innovation and high-quality solutions. The benefits of open source extend beyond just the code itself. They include transparency, which allows developers to understand how projects work, accessibility, which makes it easier for new contributors to get involved, and collective problem solving, where challenges are tackled through the combined efforts of many. Moreover, open source encourages learning and mentorship, as developers can study the code of others, contribute to projects, and receive guidance from experienced members of the community. This environment not only accelerates the learning process, but also helps build a culture of shared growth and mutual support. Contributing to Ruby projects is an excellent way to get involved with the community and make a meaningful impact. The journey begins by exploring GitHub repositories, which host the majority of Ruby projects. These repositories often have issues labeled Good First Issue or Help Wanted, which are perfect starting points for newcomers. By identifying these issues, you can find tasks that are suitable for your skill level and begin working on them. Once you have a task in mind, the next step is to fork the project, which creates a copy of the repository under your account. This allows you to make changes without affecting the original code base. After making your changes, you can submit a pull request, which is a way to propose your modifications to the project maintainers. It is important to follow the project's coding standards, as this ensures that your contributions are consistent with the rest of the code base. Additionally, writing tests for your changes is crucial, as it helps verify that your code works as intended and does not introduce any new issues. By following these steps, you can actively participate in the development of Ruby projects and contribute to the ongoing growth of the ecosystem. When contributing to open source projects, adhering to best practices is essential for ensuring that your work is accepted and valued by the community. Clear communication with maintainers and other contributors is the first step in this process. Whether you are asking for guidance, reporting an issue, or providing feedback, being articulate and respectful helps build trust and facilitates collaboration. Writing clean, well-documented code is another critical aspect of open source contributions. Clean code is not only easier to understand, but also more maintainable, which benefits the entire community. It is also important to respect the project's guidelines and licensing, as these rules are in place to ensure consistency and legal compliance. Finally, being patient and open to feedback during the review process is key to successful contributions. The review process is an opportunity to learn and improve, and maintaining a positive attitude will help you navigate any challenges that arise. By following these best practices, you can become a more effective and valued contributor to the Ruby community. Real-world examples of Ruby contributions highlight the impact that individual and collective efforts can have on the ecosystem. Contributions to the Ruby core, such as performance improvements and bug fixes, demonstrate how even small changes can lead to significant enhancements in the language. Open source gems like Active Record, which provides an object relational mapping system for Ruby, Sidekick, a background job processing library, and RSpec, a testing framework, have become essential tools for many developers. These gems are maintained by the community and continue to evolve through contributions from individuals and organizations. Community-driven initiatives like Ruby Together, which supports the maintenance of critical gems, and the Ruby Association, which promotes the use of Ruby in various industries, further exemplify the collaborative nature of the Ruby community. Developer stories, such as those of individuals who started as beginners and gradually became core contributors, illustrate how contributions can shape the future of the ecosystem and inspire others to get involved. These examples show that every contribution, no matter how small, plays a role in the continued success of Ruby. The Ruby community and open source culture are the driving forces behind the language's innovation and growth. This community is a testament to the power of collaboration, where individuals from diverse backgrounds come together to share knowledge, solve problems, and create high-quality software. Everyone, regardless of their experience level, has the opportunity to contribute and make a difference. By engaging with the community through discussions, events, and contributions, you can help shape the future of Ruby. Collaboration is not just about writing code. It is about building relationships, supporting each other, and fostering a culture of mutual respect and learning. Embracing the spirit of open source means being willing to give back, whether through small fixes, documentation improvements, or larger contributions. As you continue your journey with Ruby, remember that your participation, no matter how modest, adds value to the community and helps ensure the continued success of the language. By staying involved and contributing your skills and time, you become part of a larger movement that thrives on shared effort and collective progress. Real-world Ruby applications are programs designed to solve specific problems or fulfill practical needs in everyday scenarios. These applications range from web-based tools and automation scripts to complex systems that power businesses. The purpose of such applications is to deliver value through functionality, efficiency, or user engagement. Practical coding skills are essential because they bridge the gap between theoretical knowledge and real-world implementation. Without these skills, even the most well-designed concepts remain abstract. In this session, we will focus on building a functional app from the ground up. This means we will not only learn Ruby syntax, but also apply it to create something tangible that works in real environments. By the end, you will have a clear understanding of how to translate ideas into code. To begin, we must identify user needs by asking questions like who will use the app, what tasks they need to perform, and what challenges they face. This helps us define functional requirements, specific features the app must have. Next, we determine the scope of the project, which involves deciding on core features versus optional ones. Understanding the target audience ensures the app meets their expectations. Once we have clarity, we create a project roadmap. This includes breaking the work into manageable tasks, estimating time for each, and setting a timeline. A well-structured roadmap keeps the project on track and helps us celebrate milestones along the way. Setting up the development environment is the first step toward building your app. We start by installing Ruby, which is the programming language we will use. Alongside Ruby, we need to install dependencies such as the Ruby Gems package manager and any libraries required for our project. Version control is crucial for tracking changes and collaborating with others. Git is the most common tool, and we will configure it to work with platforms like GitHub. Finally, choosing the right IDE or text editor can enhance productivity. Popular options include Visual Studio Code, RubyMine, or Sublime Text. Each has features tailored to Ruby development, so select one that aligns with your workflow. Organizing your project's files and directories is vital for maintainability. A well-structured project makes it easier to navigate, update, and collaborate on code. We will follow conventions like MVC, which separates the application into 3 components. The model handles data, the view manages the user interface, and the controller acts as the intermediary. This separation ensures clarity and reduces complexity. Additionally, we will include configuration files such as env for environment variables, gemfile for dependencies, and setup scripts for initializing the project. Proper organization also extends to environment setup, ensuring the app runs consistently across different systems. Implementing core features begins with user authentication and authorization. This ensures only verified users can access specific parts of the app. We will explore methods like hashing passwords and using tokens for secure access. Next, we develop the business logic that drives the app's functionality. This could involve processing user inputs, handling transactions, or managing workflows. For example, if the app is an e-commerce platform, we will create logic for adding items to a cart or processing payments. Integrating third-party APIs or libraries expands the app's capabilities. We might use services like Stripe for payments or Twitter for social features, leveraging existing tools to save time and effort. Database integration is where the app stores and retrieves data. We will design a database schema using Active Record, which is Ruby's object relational mapping tool. This involves defining tables, columns, and relationships between data entities. Migrations will be used to create and update the database structure, while seed files populated with initial data. Efficient querying is essential for performance, so we will learn to use active record methods to retrieve, update, and delete records. We will also discuss best practices like indexing and avoiding unnecessary queries to ensure the app handles data smoothly even as it scales. Testing and debugging are critical to ensuring the app works as intended. We will write unit tests to verify individual components, such as models or helper methods, and integration tests to check how different parts interact. Tools like RSpec or Minitest will help automate these tests. Debugging tools like Bybug or Pry allow us to step through code and inspect variables in real time. Common errors, such as null references or incorrect data types, will be addressed by analyzing stack traces and using logs. systematically testing and debugging, we ensure the app is reliable and handles edge cases gracefully. Preparing the app for production involves several steps to ensure it runs smoothly in a live environment. We will configure environment variables to store sensitive information like API keys, avoiding hard-coding them into the code base. Choosing a hosting platform like Heroku or Render simplifies deployment, as these services handle server management. We will also set up dependencies, ensuring the app's gem file is correctly configured. Finally, we will test the app in a production-like environment to catch any issues before launch. This step is crucial for providing a seamless experience to end users. The final review and refinement phase focuses on improving the app's quality. Code reviews help identify potential issues and ensure the code adheres to best practices. Performance optimization might involve reducing load times or minimizing resource usage. Polishing the user interface and user experience ensures the app is intuitive and visually appealing. We will also document the application, creating guides for users and future developers. Documentation includes explaining how to install, configure, and use the app, making it easier to maintain and extend over time. In summary, this session has covered the entire life cycle of building a real-world Ruby application. From planning and development to testing and deployment, we have explored key concepts and practical skills. The goal is to equip you with the confidence to tackle your own projects. Practice is essential, so I encourage you to experiment with different ideas and apply what you've learned. For further resources, consider exploring books like The Ruby Programming Language, online courses, or communities like Ruby on Rails tutorials. Collaboration and continuous learning are vital in the ever-evolving world of programming. Keep building, keep learning, and enjoy the process. Good day. Today, we will explore advanced Ruby concepts that go beyond the basics of syntax and object-oriented programming. These topics are essential for developing applications that are not only powerful, but also scalable, efficient, and easy to maintain. By the end of this session, you will gain a deeper understanding of Ruby's capabilities, from meta-programming to performance optimization, and how these features shape the future of Ruby development. Let's begin by defining what makes Ruby's advanced features unique and why they matter in modern software engineering. Metaprogramming in Ruby is a powerful technique that allows developers to write code that can modify itself or generate code at runtime. For instance, the define method enables dynamic creation of methods, while method missing allows handling undefined methods gracefully, which is often used in frameworks like Rails, Active Record to provide flexible query interfaces. Additionally, methods like eval, send, and instance eval let you manipulate code dynamically, making it possible to build domain-specific languages or customize behavior on the fly. These tools are not just theoretical. They are widely used in real-world applications to create expressive and maintainable code bases. Concurrency and parallelism are critical for building responsive and efficient applications. Ruby's threading model, however, is constrained by the global interpreter lock, which prevents true parallel execution of threads. To work around this, developers often use fibers, which are lightweight threads managed by the application rather than the operating system. Libraries like Event Machine leverage fibers for non-blocking I/O, enabling high-performance network applications. For CPU-bound tasks, the parallel gem allows you to distribute work across multiple cores, making it possible to harness the full power of modern hardware. Understanding these approaches is key to optimizing Ruby applications for performance. Performance optimization in Ruby involves a combination of profiling, memory management, and leveraging modern compiler improvements. Tools like RubyProf and Benchmark help identify slow sections of code, while careful use of data structures and avoiding memory leaks ensures applications run smoothly. With Ruby 3x, the introduction of YJIT, yet another JIT compiler, has brought significant speed improvements, making Ruby a viable choice for performance-critical applications. By analyzing and refining code with these techniques, developers can create applications that are both fast and resource efficient. Ruby 3x introduces groundbreaking features that enhance both performance and developer experience. YJIT, a just-in-time compiler, dramatically improves execution speed, making Ruby faster than ever. Keyword arguments provide clearer method signatures, while pattern matching in Ruby 3.1 simplifies complex data manipulation. Additionally, the Ruby type system RBS offers optional type checking, helping catch errors early and improving code reliability. These innovations position Ruby as a language that continues to evolve, adapting to modern development needs while maintaining its flexibility. Functional programming concepts, though not native to Ruby, can be integrated to improve code quality and maintainability. Immutability, where data is not changed after creation, reduces side effects and makes code easier to reason about. Higher order functions, such as map and reduce, allow for expressive data transformations. Gems like DryRB and Ramda provide functional programming utilities, enabling developers to write cleaner, more modular code. By combining these paradigms with Ruby's object-oriented nature, you can create systems that are both powerful and easy to maintain. Ruby remains a strong force in web development, with frameworks like Rails 7 introducing modern tools such as Hotwire, Turbo, and Stimulus. These technologies reduce reliance on JavaScript, enabling faster page loads and a more seamless user experience. The shift toward API-first development and microservices architecture allows Ruby applications to scale efficiently, while integration with front-end frameworks like React and Vue opens new possibilities for full-stack development. By staying current with these trends, Ruby developers can build robust, future-ready web applications. While Ruby is not the first choice for AI and data science, it offers tools like Daru for data analysis and SVM for machine learning. These libraries enable rapid prototyping and automation, making Ruby a useful tool for specific use cases. However, compared to Python's extensive ecosystem, Ruby's offerings are more limited. That said, the community is actively working to expand Ruby's capabilities in these areas, ensuring it remains relevant for niche applications and automation workflows. The Ruby community has grown significantly, driven by the expansion of Ruby gems and improved package management tools. Initiatives like RubyConf and local meetups foster collaboration, while open source contributions continue to shape the language. Efforts to enhance inclusivity, documentation, and tooling ensure that Ruby remains accessible to developers of all skill levels. This vibrant ecosystem is a testament to the dedication of its community, which plays a vital role in Ruby's ongoing evolution. Looking ahead, Ruby's future holds exciting possibilities. Enhanced concurrency models may address current limitations, while the adoption of type systems and static analysis tools will improve code quality. As Ruby expands into domains like edge computing and IoT, it will find new applications in emerging technologies. By staying attuned to these trends, developers can position themselves at the forefront of Ruby's next phase of growth. To recap, we've explored metaprogramming, performance optimization, concurrency, and Ruby's evolving features. These topics highlight the language's versatility and its ability to adapt to modern challenges. As Ruby continues to grow, its community and innovations will remain central to its success. I encourage you to delve deeper into these concepts, experiment with new tools, and contribute to the Ruby ecosystem. The future of Ruby is bright, and your involvement can help shape it. Thank you. And just like that, our dreamy coding adventure has come to an end. I hope the gentle ebb and flow of the tutorial, combined with the tranquil melodies, have left you feeling both informed and at ease. Whether you managed to catch every line of code or drifted off into a peaceful slumber, remember that the world of Ruby will always be here waiting for you. Keep your code clean, your mind open, and your spirit relaxed. Don't forget to subscribe to Code Snooze so you never miss out on another soothing coding journey. Hit that like button if this video brought you a moment of calm and learning, and share it with fellow coders or anyone in need of a serene study session. Thank you for joining me in this cozy corner of the internet. Until next time, may your code run smoothly and your dreams be filled with brilliant algorithms. Sweet dreams, sleepy coders.